Hey, everybody. We have 52 watching already, which is pretty awesome. And what a show we've got lined up for you this evening. We have Don from Say What? I think that's the channel. Say What? But we're going to call him Don. 9,900 subscribers on his channel. So Don's here, and he is a globe earther, and essentially we have Brian. Again, called to the forefront of this particular show for what is perhaps the 10th time I would say that you've been on here, Brian. But anyway, Brian's here again. Brian's Logic. He will be debating Don on the shape of the Earth. So without introducing you again, can you do a mic check for both of you, please, just to check that everything's coming through fine?
Hello.
Yeah, I'm here.
Hey, I can hear you both very well. Coming through good. Coming through good. Right, so let me just get this right. So I think Brian got in touch with me because he said that you two had been having some kind of altercation and wanted to get into some kind of debate. Is that correct?
I mean, I wouldn't say it was an altercation. We just talked back and forth. I try not to do too much arguing, you know.
Okay. And
yeah, originally we were supposed to go on to modern day debate, and he just hadn't gotten back to us. He hadn't got back to me anyway. So I said, look, if you want to do it, we'll do it on Ranties. And I said, have a look at Ranties. He's a good moderator. And you had done two debates just the day previous, so Don was happy enough with that.
Okay.
Absolutely.
Good stuff. So I assume there's going to be a whole wide range of topics because there's no actual topic been set in stone. So I don't care if it jumbles all over the place and goes here, there and everywhere. Right. Just be aware that, you know, at certain points, you know, I'm sure Brian will at some point mention things like pseudoscience or a presupposition or things like this. And words have meaning, so you know, if he does bring these up and you need some kind of clarification as to where this might be going or what's going on with this particular wordage that we're using, that might help progress this debate as we go through it. Is that okay with you?
That's absolutely fine. Excellent.
Right, so I'm going to pop you guys on. Let's see. Let's get you on Skype. Right, so you're all ready to go, and I'm going to pop myself on mute, and I'm going to let you guys get into it. Here we go.
Okay.
All right.
So I'll leave you start on. If you want to start on whatever topic, the sun or whatever, we can start wherever I'm easy.
Okay. I'm if you don't mind, I'd like you to I don't want to assume that I know what you believe, because let's be honest, there's many different things that different flat earthers believe. So can you tell me what you believe? What your beliefs are as far as how, you know, where the world is.
Yeah, as far as flat earth goes, well, the basics of it is I try not to get lost in the conspiracy side of things as much. I basically believe that we're within a construct, that we're on a flat plane that's motionless, that there is a barrier of some kind above us. Now, I'm not stating it's a dome. I don't know what it is. But there is evidence to support that there would have to be a barrier. Basically, I try and go with whatever I can get proof for, or some evidence for. And I'll be honest with you, a lot of what I do is more over the past couple of years has been more trying to find out how true some of the stuff is we've been taught over the years is. So basically, I don't have any particular model as far as the flat earth goes, just that we are within an enclosed system and it's flat and motionless. Other than that, I don't make any major claims because I can't. You know, that kind of.
Do you believe that the sun is inside the dome, outside the dome? What is your belief on the sun and the moon?
Well, my belief personally on the sun and the moon is that it would be within the enclosed system. As I said, I don't know if it's a dome. A dome does make engineering sense because a dome ceiling is the strongest built ceiling you can have as far as engineering goes, but it's the most difficult to build also. So it is extremely strong because it supports every part of it, supports every other part of it. So it would make sense, and other things would make sense that it could be a dome, but I don't have proof that it's a dome. So I just call it a barrier, let's just say. And I do believe that the sun and moon are within that. Yes, I do.
Okay, so how would you, if you believe that there is a dome of some kind, how do you explain the pressure gradient? How do you explain that when if we were inside of it, if we were an enclosed system and it was pressured, it would be equal from top to bottom? How do you get around that with being inside of an enclosed system?
Yeah, I understand that question. Yeah, we see when majority of all examples that we have concerning gas pressure involves being within a container and it's an equalized pressure. But the difference between what we're in and a gas and let's say a cylinder of gas is we are in what's known as a closed dynamic system. We have gas cycles that are constantly on the go, and the gas is being produced at ground level. And different gases have different densities, so they organize themselves within density majority of the time. Now there is some exceptions to the rule, but that's because of cycles. That's down to gas cycles. So basically, it's down to temperature, gas cycles, and relative density equilibrium. That's how we have the gradient. I mean, the gradient can be and has been shown within a container as a demonstration a couple of times. I think it was Good Times for All was the first to do it. Go on, sorry.
Well, okay, so if we have a sun and a moon that cycle, so I'm taking it when you say you think that they are local, then you believe that in the sun switching positions from the Tropic of Cancer and Capricorn, then, correct?
Yeah, it still has to do that. There was the original solar analemma. I don't know if you know much about it, because the solar analemma we were told about is actually not really a solar analemma, because the sun is not doing anything. It's more of an earth analemma that was devised by Kepler. And basically, Kepler took the original solar analemma, because Kepler was an astrologer and he knew about the original solar analemma. He took the original solar analemma and he amalgamated it with the Copernican model, which put us going around the sun as opposed to the sun going around us. And he amalgamated the two, because the Copernican model was basically a simplistic idea until Kepler got a hold of it. And so he amalgamated the two. But the original solar analemma had the sun at different heights in the sky and moving at different speeds and making different size, let's say, consecutive circles around us throughout the year. For instance, this time of year, the sun would be low in the sky, at its lowest in the sky, making its fastest circle and making its widest circle. And that's why when in the northern part of the world, when we talk about the low winter sun, that's what we're talking about. The sun is low in the sky. Often the time, if you're driving the low winter sun in the northern part of the world, the low winter sun will affect you when you're driving, because it's coming straight into the windscreen at like 3 o'clock in the day or whatever. So
okay, so with that though, with the model that I've seen the model you're talking about, and with my issues with that is that in any position on Earth that we would be, like, let's say you're in Ireland, correct?
Yeah.
Okay, and I'm jealous of you, and I hate you for that. But anyway,
I'd like to be in the US. Go on, sorry.
I'd trade you any day. I live in Ohio. We would see different phases. We would see different phases of the sun, or I mean the moon. The moon would be in different phases. There's no way around that. There's no way around the fact that we don't see the sun switch positions. We don't see that difference. We don't, as far as, I'm sorry, I misspoke. We don't see the speed up of the sun that it would have to do to jump from one tropic to the other. You understand what I'm saying? Yeah, it would have to slow down throughout time. And the big thing of that would be that in that model that I've seen, we only see one side of the moon. People on one side of the planet would see the back of the moon, while the other people would see the front of the moon, the side of the moon, the other side of the moon. Okay. I mean, it just doesn't correlate with reality as far as what we see.
before you go too much, well, let me answer what you're after, or just saying, and then we move on to the next. You can critique the rest after. You can ask me more after that, so we just don't get lost in it.
Right.
As far as the moon goes, like there's only one moon, and whatever the phase of the moon is, the phase of the moon for the whole world. If I'm looking at the moon from Ireland and you're looking at it from Ohio, we're going to be looking at it from two different angles. So it's going to be the same phase of the moon, but we're going to see it in two different ways. Because I lived in Australia, and in Australia, the moon looks it's not exactly upside down, but it's almost upside down from how I see it in Ireland. Because where I was Sydney was 33 degrees south. I'm in Ireland, which is 52 degrees north in southern Ireland. So it wasn't exactly upside down, but it was close to being upside down from how I see it here. And it's just we're looking at it from different angles. Now, I don't make any claims about the moon because the moon is something I'm looking into. It's a pretty mysterious thing. I'm not after doing enough research on the moon to start having any major debate concerning the moon because I don't know. I'm not going to claim that I know everything there is to know about the moon.
But we can both agree that we both see the same thing in the sky, correct? Yeah,
it's the same moon. We're seeing the same moon just from different angles.
But not really. I mean, if you look at it if tonight is a full moon or a half a moon, you see the same half moon as I see. You don't see the other half of the moon. You see that same half the moon that I see. Yeah,
the moon is pretty mysterious. I mean, we both see the same half of the moon. And we might see it from a different angle, but it's still the same half that's blocked and the same half that's not.
What I'm saying is that if you're more along a line of, like, let's say from my position, if you're further, let's just say east, which you are, I guess if you want to look, you can go east or west, but let's just say, for instance, I'm in Ohio. I started Ohio at sundown, sundown, as soon as the moon comes up. Yeah. And I travel to Ireland. As I'm traveling towards you, if I'm going in an easterly direction, that would mean that the further I move, the more of the moon I would see. You understand what I'm saying? In other words, the shadow of the moon would move with me.
Well, I don't know. See, I can't argue for what the moon would or wouldn't do. But I honestly have no idea what the moon is. I don't know. That's pretty mysterious object.
That's just shadows and angular, that's just basic angular perception.
Well, it depends on what you like. Do you believe the moon is like a rock? You believe the moon is a rock, like a rock that's 240,000 miles away?
Absolutely, a rock. Absolutely.
Yeah, and it's shadowed by the phases are caused by the Earth, the shadow of the Earth. Yeah? Is that what the phases are caused by in that model?
Say what?
The phases are caused by the shadow of the Earth.
No.
I don't know how the phases are caused in that model. I'll be honest with you, I don't. As I said, the moon is something I haven't really looked into.
The phases on the moon are caused by the direction of sunlight.
Oh, sorry, the direction of sunlight. Yeah. Sorry, I get things mixed up with that model. But the direction of sunlight. Yeah, sorry. Yeah, but the thing about this is that you already have a pre-assumption that the moon is a rock that's 240,000 miles away, and so that's why you're reckoning the moon should do X, Y, or Z as you move east. But I don't know what the moon is or why it does what it does.
You say I have a presupposition of that, but yet I've took that from my own observations with my own telescope. What I see, I can look at something and see, hey, that looks like a rock. Or I could say, oh man, that looks like a mushroom. I could tell the difference between a rock and a mushroom, a rock and an orange. You know what I'm saying?
Okay. I'll accept that. No, don't get me wrong. I'll accept it looks like a big sphere. Right, and it looks like it's a solid, but I don't know that it's a solid. I don't know what it is. I can't argue about the moon, but technically you can't either because you don't know. You can only go by what you see, and I've seen the moon through a telescope, and it does look like that, but I don't know what it is, and I don't know why it has the phases. Those phases are explained on the flat Earth. It's just not something that I've looked into. Other people have explained those phases. So it's not as if they're not explained. It's just I don't have to explain.
I have to disagree with that, Brian. It can't be. That's impossible. It can't be. The moon shadows phases can't be explained on flat Earth because it would be different. It would be different as you travel, and it would be different anywhere you know.
Yeah, but see, you have the belief that the moon, the light. See, this is the thing about it. You believe that the moon phases in your model are caused by the sunlight, hitting the moon. You believe
Well,
the moon is lit. You believe that the moon is lit by the sun. Isn't that right?
do you think that it's its own light?
Yeah, I don't believe it's lit by the sun at all because
Show
of the
me.
way it's lit. I don't believe that it's lit by the sun.
Okay. Well, then, can you show me any example, Brian, of a light source with shadows on it? Any example at all?
Of light source with shadow. Well, you can do that with light inside of a sphere. You can create things and that will allow you to dim the light in one part of the sphere and give light to the other part. I mean, that's not impossible. Like, if you know what I mean, it's like you have to understand. You're working off of the belief that it's the sun, that the sunlight that's causing the light on the moon, whereas
Okay,
I don't
you're saying-
believe that. I believe the moon has its own light. Because how does the moon reflect light when it's a sphere? How does a sphere reflect light in the way the moon is supposed to do it? It doesn't make logical sense.
Okay, well, can I ask you? Do you know what they say that is made? The moon is made of?
Well, mainstream science says it's a rock, isn't it?
Regolith, right?
Yeah.
Right. Okay. Do you know the reflective capabilities of that?
Of rock.
No, of what? Okay, so I mean, I understand what you're trying to. I understand, but okay, look, I'm not a moon expert either. I just know that you know it can't be its own light source because it has shadows on it, and you can't make
we don't know what the moon is to say what it can and can't do.
Well, I mean, we've been to the moon, so how can we not say that?
Well, look. The thing about it is, before we go into the thing of going to the moon, that's a separate argument because that involves going into space, which is a separate argument again. So if we go into that, we'll be jumping. I don't mind if we go into that a bit later, but we'll stick on the sun and the moon for the moment.
Okay, all right, yeah, that's fine. Okay. All right, so then how come also then? All right, then you're saying that we have a local sun. Can you explain why the angular size of the sun doesn't change throughout the day? Because you can't get away with saying that the sun is local and it revolves in a circle around us, but yet, and depending on where you're at on the Earth, as it comes closer to you, it would get bigger, and as it moved away from you, it would get smaller, and it doesn't do that. The angular size of the sun does not.
I want to answer that question, right? But first, I just want to answer something you said a few minutes ago about the sun, right? You said we would have to see the sun moving slower and faster, right? That's what you said, isn't it? That we would have to have evidence that the sun is moving slower and faster throughout the year.
Absolutely.
Yeah. But there is evidence that the sun moves faster and slower. Yeah. If you look at Kepler's analemma, we are supposed to be doing an offset elliptical orbit of the sun. And during the winter time during the southern summer, we are moving faster past the sun in that Kepler's analemma. We're moving faster past the sun and we're closer to the sun in the southern summer. And in the northern summer, we're moving slower past the sun and we're further from the sun, right? If you reverse that back to the original analemma, it's that the sun is moving faster past us and is closer to us in the southern summer. And it's the sun that's higher above us and moving slower around us in the northern summer. So it's not true that there isn't evidence there. It's just reverse engineered by Kepler. Kepler reverse engineered the original analemma. Because the original analemma was based off of observations of what the sun was doing and the belief that it was going around us.
All that aside, Brian, you can't change what we see. No scientist can change what we observe, and we do not observe the sun moving faster or slower through the day, and we do not also observe the angular size of the sun.
That's like it's not me making that up. Even if you Google does the sun move faster across the sky in the southern summer, you'll get a thing about it saying it appears to move faster in the sky in the southern summer.
About throughout a day, Brian. I'm not talking about throughout a year. I'm talking about.
But I'm talking about the southern summer. That's what I'm talking about, and the northern summer. This is part of your model.
Brian, we would notice that daily, not at certain times of the year. We would notice.
It's explained throughout the certain times of the year. It's not explained. You understand? It's moving faster now than it will be in June. Do you know what I mean?
No.
And that's
Okay,
but it's the same thing. It's exactly the same thing, Don, in your model. Your model states the exact same thing. It's just reversed. It's that we're going faster past it as opposed to it going faster past us, or we're going faster or slower past it in the northern summer as opposed to it going slower around us in the northern summer. It's the exact same thing, just reversed.
Brian, I'm talking about in a day. I'm talking about when I wake up in the morning.
Yeah.
I would notice that it changing throughout the day. It would have to. It would have to do that to keep the.
What do you mean by changing in its speed?
What?
Changing in its speed or its rate during the day.
Yeah, it would change its speed.
No, like at the moment, its speed will be constant. It won't move faster today and slower tomorrow. It won't be that. It's a gradual change. It'll gradually start becoming slower from this point on, and it'll gradually start becoming faster from September. From September on, it'll start to go faster again. It's more like once it goes to the equinoxes, it really, let's say after the March equinox, it'll really start to rise in the sky and go slower. And after the September equinox, it'll really be much lower in the sky and go faster. But it's a gradual thing. It starts, let's just say, at the June solstice, where it's moving slowest and it's at its highest. And then when it starts to move a little bit faster and drop in the sky, all the way through the September equinox. And then when it reaches the December solstice, it's moving at its fastest, and it's moving and it's at its lowest in the sky. And then it'll start slowing down when it starts heading towards the March equinox, and it'll start to rise in the sky. But this is a gradual thing. You won't see it day to day. Like you'd have to be studying it every day, you know, that kind of it.
Well, then explain to me the angular difference. How come we do not see that? We do not see.
But
there's no way around this, Brian. You cannot tell me that we wouldn't see.
Speak, Don. How do you know? How do you know there's no way around it if you don't leave me speak? You ask me the questions, I'll answer.
Okay, yeah.
How do you know the sun is not changing angular size? Because I have two videos I could share that show that it is. From Chris Van Matry. One from Chris Van Matry. 1 second. One from Chris Van Matry and one from Wolfie 6020. The sun gets smaller as it goes to sunset, and it's smaller. But it's very, very minimal. It's only a small amount. But
it does change. The angular size of the sun does not change from sun up to sundown.
Changes a very small amount, and I tell you why.
If you're not viewing the sun through a proper solar filter,
but Wolfie 6020 is on your side. They use the solar filter.
I'm just telling you, unless it's with a proper solar filter that does not have glare, it's a garbage video. Redder did the same sun observation and took every 30 minutes, and the sun did not change in angular size at all.
Hang on, wait a minute. Could I intersect for just a second? So I see that you're going a bit back and forth about it does change size, it doesn't change size, etc., etc. I'm assuming that nobody's got any evidence of that to present right now.
Well, I don't want to go present in a video unless Don has his video to present.
That seems fair. That seems fair.
If you have the video, I want to see it.
Okay, there you go, Brian. If you want to present,
I'll have to go get Chris Van Matry's video.
In the meantime, if you could just, for the audience's sake, if you could just clarify what you actually think these celestial bodies are, and what their effect and what what you're arguing about right now, how that goes to actually proving the shape of the Earth. Thank you.
Is that for Don or for me?
That's to both of you.
All right. Well, for me, the celestial bodies don't have any connection to the shape of the Earth. For me, for me, they don't they're what's going on up above us. So whatever is going on above us is going on above us. Whereas the shape of the Earth is not dependent on whatever they would do. That would be my thinking on that. All
right. And as far as I'm concerned, the sun proves a globe when it rises and it sets. We can observe other bodies in the solar system, and without ever leaving Earth, without us ever having left Earth, which we have left Earth and we have went to space, we have went to the moon. But other than that, without that, I can throw the moon landing under the bus and say we never went, and we can still come to the conclusion that in space Gravity tends to make things spherical. We observe that through telescopes with every other lunar object that we can see. So unless we're some kind of special, case, why would everything around us be a sphere and us not be one? We can measure, we can take sticks and measure the size of the earth, and we can also see that the earth is round just by the shadows of them. We can, like I said, we can see the sun drop down behind the horizon every day, and we can see it come back up every night or every morning. So,
sorry, go on.
And without that, that's my reasoning for saying that that's my correlation between the lunar objects and Earth being around, is that the main thing is the sun. The sun setting and the sun rising is absolutely proof that we live on a globe. Absolutely. To me, that is a flat Earth killer. To me, the sun setting and rising every day is an absolute 100% flat Earth killer. You cannot, and no one. The difference, if the sun was local, the sun would change in an angular size 5 times the size that we see it through the day. That's the difference from the time the sun comes up in the morning to the time it spins around us and inside our dome to get up over our head. It would be 5 times bigger from when we first seen it rise, and then it would disappear and become like every other thing that did get with the angular size gets smaller and smaller the farther away it gets. It has to obey the laws of perspective, just like a boat does the further away it gets. It has to diminish in angular size if it moves from us. You can't get away. That is
Let me respond to that. For a start, I don't know what the sun is. None of us know what the sun is. Right? Number one is, when you're seeing the sun, often the time you're not actually still seeing that sun. You're seeing a mirage of the sun. You're not actually seeing the sun. This is not like a flat Earth thing. This is a known thing, right? Mainstream science, that the sun is in a not actual location. It's very, very hard. Supposedly, I've never done it, but supposedly it's very, very hard and difficult to triangulate the sun because the sun is such a mysterious object. It's where you might think it is, or I might think it is in the sky. It may not be necessarily where it actually is. So there is photographs even online. I downloaded a load of them where it shows the sun at sunset, but it's only just a mirage that's left. So the actual sun is gone from where it's actually left a mirage. The sun is actually not in that position anymore. But to explain a sunset, I'll give you an explanation of the sunset. If you think the sun, like let's just say we both agree the sun is big, right? Now we did disagree on the size of the sun, right? I wouldn't agree it's the size of and the distance that it is in the belief you have, but we both agree the sun seems to be a big object in the sky. Now it is high up, higher than anything any airplane or whatever. It's above all those kind of things, right? I don't believe it's above the stars, but it's above everything else, like as far as airplanes and else. So it's high up in the sky. Now, it's a big object and it's high up. So when that moves to the point of what's known as the diffraction limit, your diffraction limit will be like your horizon. It'll be the point where you visually can't determine what you're looking at anymore. It's like where the sky and land or sea seems to appear to meet. But by the time that reaches that is such a big object, right? And it's so high in the sky that when that reaches that, what happens to it is the bottom of the sun starts to become part of your diffraction limit. The further it moves away, and the further it keeps moving away, your diffraction limit. One second. Your diffraction. Let me finish it. It reaches your diffraction limit, right? So your diffraction limit on a normal day for a normal person is about 3 miles away. So is that sun 3 miles away from you? No, it's not. So it's reaching your diffraction limit. You basically can't follow that sun. Right? That sun is so big, it's not gone to the point where it can really change any major angular size. It has only changed very small, a minimal amount. It's gone because it's so big and it's only going in your vision, right? It's literally the bottom of it is reaching your diffraction limit, which is 3 miles away. So as soon as that hits that, then it starts to disappear from the bottom up, like every other thing does. Everything disappears from the bottom up. And I agree, it is a mysterious object, and it is definitely something that people would find hard to figure out how this can happen, a sunrise and a sunset on a flat Earth. But that is how it happens. That is how it's happening.
The sun. So you're trying to say that the sun moves farther away from you, and then we just can't see it no more.
Well, the sun, your diffraction limit is 3 miles away.
Do you know? No. Okay, tell me what diffraction is, Brian, because I don't think you know what diffraction is.
Your diffraction limit is when things start to amalgamate and become too small for you to decipher what they are.
No,
so the average person, like the horizon, is the diffraction.
Do you know what? Give me the definition of diffraction.
What do you want to give you like off the internet?
Tell me what diffraction is, because that doesn't explain
diffraction. Is when things start to amalgamate, when you can't decipher can't decipher the details of them from the background. Like the horizon is a diffraction.
You're just saying that when a light wave is reshaped. Basically,
you can't. Like for instance, and when you go to I'll give you a good example of it. When you go to an eye test and you see the eye chart, when it gets to the point where you can't read the letters they're asking you to read anymore on that eye chart, that's your diffraction limit. It's because the diffraction limit has stopped you from deciphering what that letter or that number is on that chart. You just seen a blow.
Are you saying refraction or diffraction?
Diffraction.
Okay. Diffraction. All diffraction is the reshaping of a light wave. That's all diffraction, and that's the definition of diffraction is the reshaping of a light wave.
Are you talking about the Rayleigh criterion, where it's two light sources amalgamating into one?
It could be anything. It could be it's just a reshaping of a light wave. Brian, that's what diffraction means.
So I'll give you an example of diffraction. Right, this is something that Nate Oakley. There's an example of his example, and it's a really good example, so I'll use it. Right, if you have a brick, a normal red brick, right,
mm-hmm.
and that brick is let's just say 10 foot away from you, you can see it. But if you put that brick on a totally flat plane, a mile away from you, you won't see that brick because its angular size has become too small. You won't see the brick because its angular size has become too small. But if you build a 20-foot wall on top of that brick, you'll see a 20-foot wall, but you won't see the brick at the bottom of that wall. That's the diffraction limit. That's when you see a bird flying away from you, right, into the distance, and suddenly it just becomes a dot, and then you can't decipher the bird from the background, from the sky in the background. That's the diffraction limit.
I'm pretty sure. I mean, I'm believing that that's more of perception than diffraction. But
diffraction is to do with vision. It's to do with your vision. It comes from originally, like the study of the Rayleigh criterion started with people using microscopes because things became so small they just couldn't decipher what they were looking at.
A diffraction, here's an example. Here's my definition of a diffraction. Diffraction would be, let's say you're looking over on a really hot day, and you're looking out in the distance, and you see, like when you're driving down the road and you see heat coming off the surface, and everything above that heat is kind of like jumbled up. You know what I'm talking about?
But that's not. That's not diffraction. That's mirage.
Yeah, reshaping of light. That's all diffraction is.
But that's a mirage. That's a different thing from a diffraction. Diffraction is part of your vision.
That's diffraction is just reshaping of light. That's what diffraction is.
But diffraction is it can happen to any optic. It's just an effect of optics.
Yeah, it is. I agree with that. It absolutely is. But for what you're saying is that would have to happen absolutely every time, exactly at the same time, every day, no matter under any atmospheric condition, and that's just not reality.
It depends on what your horizon of the day is. I mean, if you've got a clear good clear day, your horizon will be further and higher. But if you have a muggy day where it's a lot more cloudy and bad weather, the horizon line will be closer to you and lower. So it depends on your horizon, like of the day. An average day, I think it's 3 miles or 3.5 miles is the human limit.
The horizon's the horizon. Horizon's, the horizon is just where the Earth starts to curve away from you.
But see, that's a belief that was never proven.
Oh, that's proven every day you see a ship floating or going away from you, and it disappears from the bottom up, and then when it comes back and it reappears from mass down.
Hold on, guys. Just because we have had a lot of talk about horizons recently, so if you could you just define terms, please? Because obviously, flat Earth and globe Earth have a differing view on what that actually is. So if you could both, in your own words, explain what you feel the horizon is, please. Thank you.
I'll leave Don go first, and I'll go after. Okay.
All right. A horizon is. I mean, I don't. Do you want me to give you an example of it, or what?
No, I think Ranty just wants to give an explanation of what you feel, what you believe the horizon to be.
Okay.
Just a rundown of what. So he wants to define terms on what you believe the horizon to be, or how you perceive the horizon and what it is in your belief.
Okay. The horizon to me is where the Earth starts to drop away from us, and it kind of creates that. I mean, I guess in layman's term, a hard line. You know what I'm saying? I mean,
yeah.
I mean, in layman, I'm trying to be in layman's term. So here's an example.
Basically, the horizon is the edge that a boat is going over. Is that what you're trying to say?
But in our field of view, it's going to be where, of course, it's going to be where the Earth's surface, and the sky meet. You know what I'm saying? But it's in all actuality, that's where the Earth's surface starts to drop away from us. But from our perspective, it just looks like the sky and the Earth meet. You know what I'm saying? That's where that hard line you see in the distance that looks like a hard line across the sky. That's the horizon.
Okay, well, my definition of the horizon is that it's where the sky and the Earth or ocean, let's just say the Earth for both ocean and land, appear to meet. That it's
right.
Basically the limit of my vision at that point. Regardless, like my horizon, like you're saying that it's where a boat goes over, but I would view that as the diffraction limit, that the bottom of the boat is disappearing from bottom up due to the diffraction limit that's happening as it goes into the horizon.
Then why
if I have good optics,
we can zoom in? You can't still see the bottom of the boat.
Well, you can. It depends on how far away the boat is.
You cannot. If the boat goes over horizon, let's say it's half.
I can show you a photograph now.
I'm pretty sure Ranty is the one that filmed the boat himself going away in the distance and disappearing over the horizon. I'm pretty sure it was his video.
It's photo specific because it depends also on the tide of the day and the swell height. That also
it doesn't matter. You can't have a tidal obstruction.
Everything matters.
If I'm 6 foot tall, the wave to block my view of that boat would have to be a 6 foot wave. If my eye level is 6 foot off the ground, you cannot block my eyes.
Angular size change will cause a swell that's small, right, be enough to block half of the boat that's bigger than the swell, but the boat is in the background. Angular size change causes this.
Parallel lines don't intersect by definition.
Angular size change. You can have a swell, a 2 foot high swell that can block, in your view, right half of a 60 foot high boat. It just depends on how far away the boat is. Angular size change. That's what that is.
That's happening when it's going over the when half the boat's already over the horizon.
When let's just say I'm looking at a boat from the beach, right, with my eyes, and I watch a boat disappear from the bottom up, right? And it seems to have gone off, right, and disappeared below the horizon. But I then take out, let's just say I have a P1000, a Nikon P1000 camera.
I mean,
And I then take out that camera and I zoom, right? Because that boat has only just gone 3 miles away from me. I can zoom and see all of that boat. But when that boat goes to about 15 miles away, then I won't be, then the bot, or maybe more, I don't know how far the zoom is on the P1000. But as soon as the P1000, that boat has gone to the point where the P1000 camera's optics, right, have reached the camera's optics diffraction limit, then it'll start disappearing from the bottom up there within the camera lens as well. It's going to do it. You can't see forever, and you have atmosphere as well. You're not going to see forever. The diffraction limit is going to cause that to happen from the bottom up.
You have things like telescopes and cameras, and you cannot prove to me, there's no flat earther that can prove to me that any camera can bring back something that's went over the horizon. If you want to talk about a foot off, what you see, wait a minute, Brian, let me finish. What you see, what you think you see a boat going over the horizon with your eyes, doesn't mean that it's actually went over that horizon. Our eyes are fallible. Our senses are fallible, and they're only good to a point. Just because you think optically with your eyes, your naked eyes, that it's went over the horizon, doesn't mean it has. If I was to take out that crap-ass P1000 that everybody likes, which I think is a crap camera, you zoom in halfway, then you have brought the angular size of that boat larger in frame, right? We agree with that, right? Through the lens of that camera. Okay. Now you can see that the boat has maybe not yet went over that horizon, but it looked like it to you because 3 miles away in our eyesight, that's going to be a tiny little boat because of, the angular size getting smaller the farther away it goes. But using that camera, we've enlarged that angular size, and now we can see it better. We've only zoomed out halfway. Now we see that it has went halfway over. So the boat is now.
But you're claiming that it will only see half the boat. That's not true.
Let me finish. The boats went halfway over the horizon. It's half gone, halfway zoomed up in the P1000. Okay, that's what I'm looking at right now. Let's just picture this.
No, it
now
I'm
going to zoom all the way in. Now I'm going to zoom it all the way in. You will not bring that whole boat back into view. You will not bring that in.
Right. Can I share a screen, Ranty? I just want to show a photograph. It is actually one of Ranty's photographs. So, can I share a screen, Ranty?
Of course you can, yeah.
Well, wasn't it you, Randy, that did the video of the boat, the big oil tanker going over the horizon?
I filmed the boat. It didn't go over the horizon, though.
It looked like it did to me.
Second now, not that one.
Well, if it was my debate, I'd happily go through it with you. But yeah.
I listened to your reasoning behind that, but that's not that. No. Do you guys? Here's my.
Sorry. Could you just confirm what you think my reasoning was for that, just so the audience know?
From what I gathered, is you're just saying that it got smaller in angular size.
No, that's not what I said.
Oh, well, maybe I watched a different one. But here's my issue: is that do you guys see that all of the stuff that you guys have got to believe, everything that you guys, the things that you say in defense of your model, well, not model, but what you believe in, it's face of science. Everything that you guys say, just like this, the air pressure. Everybody's saying how the vacuum of space would suck up all the oxygen. That's not true.
Well, we'll have that argument in a few minutes. We stick to the one more act because
hang on, wait.
We're jumping one to the other. It's not good.
But just like the curvature, you guys deny this, and it's an easily observable.
We don't just deny it. That's not true. Let's stick to the argument we have at present, right?
And call it proof.
I'm happy to go through with you after you finish your debate with Brian. If you want me to go through the boat observation, I'll happily do that with you.
I'm using Ranty's observations because they're good observations, not because I'm on Ranty's show.
No, you fire away. You fire away. I'm going to go back on mute.
Just
to say to Don, I'm not using Ranty's observations to try and get Ranty on my side in this debate. It's not like that or like that. I'm just using his observations just to show you something. This, if you can see the screen now, can you see my screen? You see the screen I'm sharing?
Yeah, I see the boat. The two boats, whatever.
Yeah. Now, this small boat, this is from a 1 foot observation height. This small boat here is probably about 7 miles away from Ranty at a 1 foot observation height. Right? There it is. There is the bottom of the boat. That's exactly how those type of boats float. I know, I've been in them many times. Right? There's the bottom of that boat. 6, 7.
Okay. What about it? What about it? Are you there?
Yeah, seeing as he seems to have lost his volume for the minute. I think what he's trying to say here is that from a 1 foot observation, the horizon should be 1.22 miles away, and at a distance of about 7 miles, none of those humans that you're looking at in that boat should be visible.
I could have swore the horizon's at 2.9 miles away.
From a 1 foot observation, you'd be looking. Yeah, you'd be looking at 1.22 miles away. With refraction, it's about 1.3.
At sea level, the horizon is usually 2.9 miles.
Yeah, that would be from a 6 foot observation. So if your observer height was at 6 feet, then you would be looking over that. So it would extend the distance to the horizon. The fact that I got down to 1 foot on this brought the horizon, or supposed horizon, closer to me, which would have placed the horizon at 1.22 miles away. In which case, that physical blockage, that hump of water, would have obscured every single thing that you're looking at in this image. I think that's what he's trying to say, but he seems to have lost his connection at the minute.
How do you know the distance of that boat?
Sorry?
For one, how do you know the distance of that boat?
Because I filmed it from higher up, and secondly, the boat is, well, wait a minute. Secondly, the boat, I can conclude it if you let me finish. And secondly, the boat in the distance that's behind that navigates a channel every single time. It can only go through that particular channel. That placed the boat at approximately 8 miles away.
So you say that little boat's 8 miles away?
No, the big boat behind it is 8 miles away.
Okay.
I'm just surmising what he's saying here. So if you guys want to carry on, yeah, I didn't really want to get involved, but you know.
Oh, that's okay. Look, I'm okay with it, man. You're all right. It's fine. My only thing is that a lot of flat earthers, they will deny refraction unless it favors their position. They won't acknowledge refraction when it favors the globe, but they will when it favors their position. Has he got it fixed yet?
I think he's got some technical issues when he shares his screen. I think it knocks him off the mic, so he's unable to do that.
Well, I've seen the video, so you know.
There you go, Brian. Yeah, I think what happens is when you share, yeah, you're back. But when you share your screen, it seems to put you on mute, or maybe you click something when you're actually sharing the screen. I'm not too sure, but if you want to try again, that would be great.
Try do it again. Yeah, I think they went anything different than they normally do. 1 second, you know. Can you still hear me now?
Yeah.
Yeah. Okay. Where's the 1 second? Now, so this boat is viewed about you're talking 7 or 8 miles away from a 1 foot observer height. Now, you said that it's not possible to see a boat that's gone over the horizon, that's starting to go what you would believe below the horizon. You said it's not possible to see the bottom of that boat.
I mean, it's not always not possible. I mean, you got to take into consideration refraction. I mean, you know, there is time. I mean, it's just like you guys, the famous.
Yeah, but for what you're talking about looming, and you need an horizon for that to loom above and beyond. But there's no horizon. You need an horizon for that.
Yeah, I'm talking about refraction.
But for what you're talking about, for anything to appear further than the horizon, that should be on going by the geometric mathematics of the globe. Anything that should appear past 1.22 miles on a 1 foot observation, for instance, then there has to be an horizon for that to appear above and behind it. There is no horizon in Ranty's observation. I'll show you another one. This is a recent one, right?
Video of refracted light.
Yeah, look, light
12
refracts. There's no one denying that.
I can show you a light refracting that's only a 15-inch light beam. It's refracting probably 3 inches.
Yeah. Is that what medium is it going through? Is it going through water or is it going through air? What way is it going through?
It's going through air.
Right. Light will refract with different temperatures and different things. Yes. But for things to come up from behind an horizon on a globe, that is called looming. Right. And for that to happen, you need to have a horizon. You have to have a horizon before the looming. You can't have no horizon and have looming. That's not possible.
I don't. Yeah, I'm telling you, you can call it what you want, but it's refraction.
No, this is not refraction.
Hang on, wait a minute. Before we go, hold on, Brian. I just want to clarify terms. I just want to clarify terms about refraction. Just before we go any further, would you agree? This is just a yes or no question. That light can bend both ways. It can refract both up and down. You can have looming and you can have sinking.
I agree.
Thanks. Right. Cheers. Carry on, Brian.
Okay, I'm going to prove to you.
Okay,
I'm going to prove. 1 second. I'm going to absolutely.
Hey, bro, let me say something real quick. That is why I don't. That's why I'm not a big fan of arguing over pictures like this, because I'm not an expert in refraction and looming. You're not, and Randy's not. Neither one of us.
Well, Randy is.
He's
Randy
not
knows refraction. He is. Randy knows what refraction is. Randy has spent. Randy. Yes, he is. I'll put him against any supposed expert out there.
Okay, well, if Randy can post his degree online here for me real quick.
He doesn't need a degree. Randy, you can put any supposed expert to do with refraction up against Randy, and I guarantee you, Randy will own him. I have no doubt about that.
Nah,
I'm going to show you something now. Right? I'm going to show you something. This will end the whole refraction argument. Okay, right? Maybe this one's better. Right, this one. This is a bit clearer. You see this, where there is a red line and a yellow line. This is from Randy's 1 foot observation. This is from the same exact observation, same exact video. The red line is where the horizon should be, right? If we were on a globe, right? Between the red line and the yellow line is all we should see. That's the very tops of those buildings that's 18 miles away. 1 second. Let me speak. 1 second. Let me speak. 1 second. Yeah. 18 miles away. Right, between the red line and the yellow line. That's all we should see of those two buildings. There are two buildings. Right, 1 second. 1 second. I'm about to end. 1 second. Let me speak. I'm about to end the whole refraction. Right, the whole refraction debate concerning this observation totally. From the yellow line up, right. That is mirage and looming. That's going on there from the yellow line up. Now you can't get a mirage from a mirage. You can't get looming from looming, right? Where that yellow line is, right? Where that yellow line is. If you want, I'll share this in the chat and you can open it up yourself. Where that yellow line is, right? There's a mirage, inverted mirage up above that, right? Up above that, looming above that. So you can't get looming or mirage from looming. It's either one or the other. Right. This completely debunks. Right. You can't. No, it's completely debunks. It completely debunks. The photograph is from 18 miles away at a 1 foot observation, right? And the only atmospheric effects are going on above the observation. It's like a mirror copy of it above the observation. So you can't have looming from looming. Or mirage from mirage. A mirage doesn't give you a mirage, and looming doesn't give you a looming. You need to have an horizon at 1.22 miles away, and you need to have
looming. Okay, right. Listen, guys. Brian, you're quoting some figures here, and you've put a red line in, and you've put a yellow line in. I just want to be sure that Don here understands the Earth curve calculator and how we can determine how much drop and how much should be missing, even including standard refraction when doing these kind of observations. Are you aware of that formula there, Don?
I'm aware of how to calculate curvature, and it's not 8 inches per mile squared.
Okay,
that is exactly.
would you like to explain what formula it is then that we should be using?
0.78 millimeters per meter.
Per meter. So not squared
Roughly.
then. So not squared then.
Basically, that's the percentage of the drop per meter.
Engineers and anyone else who would be calculating.
You can't use 8 inches per mile squared because it doesn't form a globe. It doesn't form a circle.
No,
it forms
it's good for up to 1,000 miles. It's a parabola. It's good for up to 1,000 miles.
That's more.
That's
more.
That's what is used. It's the Pythagorean theorem.
It's more flat Earth crap. That's not
comes from your side. This is from you. This is your mathematics from your side.
There are two.
No,
hang on.
This is your mathematics.
Could I just intersect one more time, please? Just one moment. Just one moment, guys. So we have
flat Earth. You're saying that it's 8 inches per mile squared, and that is not what globe earthers have ever said.
That's what the globe. Where did your globe mathematics come from? Who originally gave you the globe? 1 second. Who originally gave you your globe mathematics?
The mathematics.
Who originally gave them to you? Who gave you the mathematics of the globe? Who gave you the circumference of the globe and all the mathematics? Who gave you that?
Hang on, guys.
Trigonometry.
I need to.
Wait a minute. Trigonometry tells us how to
Who gave them to you?
Figure the dropping rate. What do you mean? Who gave it? Mathematics.
Hold on, guys, please. I really definitely do need to intersect here. So, your formula that you gave, which was how much per meter was it? How many millimeters was it? Sorry, per meter.
It's oh my god. Let me look. It's not. It's I think it's like 0.078 millimeters per meter.
Okay. So every time that you go another meter, it will drop 0.78 millimeters or something like that. Is that correct?
Hang on, man. Sorry, this I do have to look up.
The reason I ask is because if you're using that formula, it will just give you a slope.
Yeah, that's what I would say as well. You won't get how are you going to get a globe out of that?
How are you going to get a globe out of 8 inches per mile squared? You don't.
You're not supposed to get a globe out of 8 inches per mile squared. It's designed for the drop over 1,000. It's good for 1,000 miles. But
you're trying to say that my Earth looks like a parabola, and that's not the model I believe.
They use it because they don't be building things, and it's used for calculations over that just 1,000 miles. It's good for 1,000 miles.
It's not. It's not good for 1,000 miles.
It is good for 1,000 miles. Engineers, anyone who calculated stuff, use it. I don't know.
You for one, you're talking about.
Do you know where it came from? Do you know where the mathematics came from? Do you actually know who gave you the mathematics?
Figuring out the drop in the curve.
Do you know who gave you the mathematics? You're willing to answer that question.
Who gave us what mathematics? Trigonometry? What are you talking about? Who gave us what math? Mathematics in general? Hello?
I think he might have clicked his mute button again. Brian, can you just check your mute button? On your Skype, if you can hear us. Right. Are you there still, Brian?
I mean, I don't know who he's talking about. Is he talking about Eratosthenes? Or is he talking about something else? I know who gave us I know who quoted the first 8 inch per square mile, and it was the founder of the flat Earth movement. I don't know his name.
Okay. Well, you do realise that there's a couple of calculators out there written by very, very prominent globe Earth proponents, including Mick West and Walter Bislin, and both of them have an Earth curve calculator with which you can put in your observer height, distance to object, and it will give you a refracted hidden, a drop, etc. And the formula is well, it's actually 7.98 inches per mile squared, and that's essentially sufficient to actually get very, very accurate details up to 1,000 miles. After that, it kind of goes all haywire. But who in the right mind, from from sea level or even from a few hundred feet is going to see 1,000 miles. We're not. So for observations and stuff, it's absolutely fine to use that calculation, and it's well known on both sides. So I have to say, I'm just trying to. I don't want you to carry on this line of reasoning if you're in the wrong, because I'm trying to help you here.
No, I've heard the arguments. I just don't agree with it. I don't agree that is an agreeable fact when it doesn't form the shape that we say the globe is. I mean, it just doesn't. How can you start? If I start off making a circle incorrectly, I'm not going to have a circle at the end of my end of my drawing. I mean, do you understand my words? You say words have meaning, and I feel that if I start off making a circle,
can you hear me?
Wrong, it's not going to be done.
Yeah,
hear me now?
Yeah, we can hear you. The whole idea of the Earth curve calculator, as I say, it's basically for observational purposes, because nobody's expecting to actually see your own arse in a telescope. So we're not exactly just going to go around the world with infinite over 6R refraction and see your own arse in a telescope, because that's very unlikely to happen. But what we can say is that with the technology we do have, we can see for incredibly long distances, hundreds of miles. Right. So up to 1,000 miles, that calculation, although it doesn't actually give you a sphere, it does give you a very good indication as to what the missing should be on said sphere over those up to a distance of about 1,000 miles. And I'm only saying this because, I don't want you to carry on this line of reasoning, because the Globers will probably, be like, what's this guy doing? It's one of them, so I'm trying to help you.
They will, because like I just said, how can I start off making a circle, a sphere, when I start off making it wrong? If I start off making a circle, if you take a pencil and you draw a circle, and instead of starting it off as a circle, you start it off as a square, is it going to be a circle at the end of your drawing, or is it going to be some fucked up version of a circle?
Andy, sorry, 1 second, Don. Can you hear me?
Yeah. And as far as your answer, Brian, I don't know what you're meaning. I know that Eratosthenes going to come up.
You're wrong.
Yeah.
You're incorrect. I'm sorry. You're incorrect. 8 inches squared is the generally used calculation, and it has been for a long, long time.
You can't just say it drops off at 8 inches per mile squared, because you got to take observer height in the
Pythagoras. It was
take observer height into account. You have to take in refraction. A lot of more than just.
You can't go against this. You're incorrect, Don. You're wrong. You're wrong for this. You can't. You just have to accept you're wrong. I can show you as well.
I don't have to accept wrong because I'm not.
A metabone calculator. Then they'll both state you're wrong.
Oh no, they don't.
Yes, they do. They use 7.8 inches per mile squared.
Can't just say that. You have to take in observer height. You have to take in.
Didn't come from our side. The calculation from your side. Why would we make up that calculation? It's your calculation from your side. That's your globe mathematics. It's a man your globe, Don.
Okay, well, you can believe what you want. If you think that
I do not believe, Don. These are facts. These are the facts.
No, we didn't.
Right.
8 inches squared was the calculation founder of flat Earth.
Let's what about this, right? What globe outers are in the chat, right, that will say, right, that we are wrong concerning what we're saying about
whoever's it don't matter. We did not come up with that. That was something quoted by the founder of the original flat Earth movement, and it was falsely taken it was cherry picked from the whole aspect of the whole way you calculate.
I'm online with people who I know who are well-known globe outers, and they're saying you're not correct.
Well, I'm telling you that I am, and I don't care what they say.
You're not correct, Don. You just move on from this. Just accept that is not correct and move on.
That's from it. Not right, but wrong.
You're wrong. You're wrong. That's not.
I'm not. It was first
bad for you. It looks bad for you with the audience within the debate when you're not willing to admit that you're wrong on something.
When I know what I'm talking about.
I can show with I can show 3, maybe 4 curve calculators that are based on the geometry of a globe with a circumference of 24,940 miles at the equator that will use the 7.98 inches per mile squared calculation. I mean, I don't know what more to say to you.
You can't just say, oh, hey, it drops at 8 inches per mile squared. You can't just say that. Because that's not how.
Me saying that. I didn't say that. That comes from your side. That's the calculation from your side. That's not from my side.
No, it is not. This is
not a lie. I'm not making this up.
The first person
Ranty is showing here water business and curve calculator, and now he's showing the metabone curve calculator. I don't know what to say to you.
I don't either.
I'm not correct, and that's just the way it is.
No,
let's move on from this point because either you concede and we move on, or you don't concede and we move on. Because when you're wrong, you're wrong.
Whatever.
Well, it's not whatever, Don. Don, it's like if you want to debate someone, you have to be honest. You have to be willing to be honest.
Okay. You absolutely.
I'm wrong about something. I admit I'm wrong about something. I didn't try and pretend I was an expert on the moon when I wasn't.
Okay, I'd like to pull ranks here and just say let's move on because
local thing in that we shouldn't see an angular size difference in the sun that when it moves around the Earth. So let's talk about being honest. Be honest. Be honest.
What do you want me to say? But I told you about the sun. I gave you. I explained this to you.
An angular size up to 5 times bigger than it should when it passes over top of your head.
None of us know what the sun actually is.
Oh, but it's an object, Brian. It's an
object. But I gave you an explanation for a sunset. I gave you that explanation for a sunset. And I told you it does change very slightly in angular size. It changes very slightly in angular size.
Yeah, the angular size would change drastically throughout the day.
Well, it depends on what we're looking at. I don't know how big the sun is, or what's the height up in the sky it is. I don't know these things.
The size of the sun, what the sun is made of, would not freaking matter, brother. It wouldn't matter what it is. I
don't know what an object is. I'm not making claims on what the sun is. I don't know what the sun is. I gave an explanation as to how the sunset could work.
Hang on, guys. Listen to me. We've been going. Hold on, wait a second, guys. Listen, we've been going for 60 minutes already, a little bit more. We've covered a couple of topics up to now, but I'd like to move things on a little bit. And probably the hottest topic we have currently in this debate. Well, there's two actually, but one of them is gas pressure next to the vacuum of space. I mean, I'd be interested to know what your take is on that, Don. And I'd also like to know what your take is that on there, Brian, please.
Yeah, okay. If you want to move on to that, because let's go on to space, Don, because you mentioned space earlier, right? Yeah. And you were saying that they went to the moon and different things like that, right? So, and you asked me about the pressure gradient, and I explained the pressure gradient to you. Now, can you explain to me, right, how we can have gas pressure?
Salad for.
1 second.
You explain.
1 second. We have actually a gas pressure gradient. But to have a gas pressure gradient, you need to have a gas pressure in the first place. So you can't have a gas pressure gradient without a gas pressure in the first place. So how can we have that sitting next to a vacuum, right? Without any solid barrier between them, right? And all the oxygen and every other gas on our world not be taken away. Not equalize into the available volume, because that's what it will do. That's what gas does. It equalizes into the available volume.
It's called gravity. But see what you just said.
See, you can't just insert gravity. You have to actually. Gravity is not something that has ever been proven. So if you want to talk about gravity, no bother.
Just not understand what you just said contradicts yourself.
No, it's not. Okay, yes, let's start with gravity. Right. How would you define gravity for me, Don?
This was an system. The pressure would be equal.
You've inserted gravity, so we're at the point where you have to define gravity now.
Okay, gravity is a force that goes down that we can see and measure at 9.8 meters per second squared.
Right.
It's observable. It's observable. It's calculable, and it's provable. Right. You can't deny gravity. If you want to deny gravity, you explain to me.
I asked you that. Now it's my turn to talk. Right. You said, right. First of all, you said gravity was a force. Now, according to mainstream science, it is not a force, and it hasn't been a force.
Well, hang on, just a minute. I need to intersect again, Brian. Please, could you please let Don finish his entire monologue about gravity, please, and then you can do a full response because he wasn't happy that you interrupted him. So if you want to start again there, if you can, please, please, Don. And yeah, I'll hopefully Brian will shut up long enough for you to actually get that entire paragraph or whatever it is that you need to say out. Okay, go ahead.
Gravity is an apparent force. We can treat it as a force, regardless of what you want to regardless of what you want to call it. I don't care if you call it rainbow farts, reindeer farts, whatever. It is an apparent force that creates an acceleration towards the center to the center of our Earth. Regardless of what you say, you can't have level without gravity. You can't have density without gravity, and you can't have buoyancy without gravity. Period. You can't have. There's no arguing to it. It's an observable, measurable fact that we have a downward acceleration. And if you want to deny that it's gravity, then you have to explain to me what else it is. What other can it be than gravity? Because density is not an answer, and neither is buoyancy. Because everything takes the least resistance path. And to say it's density, and to say, oh, well, it's more dense than air around, then it would go up. Why wouldn't it go up? Why would it push itself down through the harder, denser atmosphere instead of taking the path that's least resistant up?
Okay.
Or side to side?
Right, will I respond now?
Go ahead.
Right.
Go ahead.
For a start, you called it an apparent force. Either you view it as a force or you don't. Second,
it's something we can act. We can treat it like
over 100 years. It's been in effect due to the curvature of space-time for over 100 years.
Brian, hold on. Sorry, I keep interrupting you, and I do apologise, but he did have a response to your first point. So your first point, which you wanted clarity about an apparent force.
What he said, Randy.
So if you could just let him respond to that one, and then move on to point two, and then you can have a chance to go back over it all in one go. So you mentioned apparent force. You have a problem with him citing it as an apparent force. Don, what would you say to that?
It is an observable phenomenon, Brian, that we can treat as a force. Doesn't mean that in the laws of physics it is an actual force, but it can be treated as a force.
Okay.
It can be referred as a force because it causes an acceleration in a vector, and it has a vector which is down.
And you had You had a second point there, Brian. Go ahead.
Yeah, well, I'm kind of after forgetting it now.
Sorry.
See, that's what happens. You see.
Yeah, I just don't want to skip there. I want to get sort of some concise points made, and then for you to get into this kind of argument about that. But he was talking about a downward force, 9.8 meters per second squared.
Hang on. My point was is that according to mainstream science, it's an effect caused by the curvature of space-time. That's what mainstream science say about it and have said about it for 100 years.
One word.
So
Space-time.
They don't mention it as a force. I could get you many citations and many videos of people who are astrophysicists and all this. They don't call it a force. Okay.
The force.
Who are at the top of the tree of your sphere belief don't call it a force, they call it an effect. Now, 9.8 meters per squared, right, is not a measurement, that's a calculation. Not a measurement.
Apparent force.
It's a calculation. You cannot show me two objects both falling at 9.8 meters per squared. Two different objects of different densities. Right?
Listen, stop using words out, Brian.
You can't show me those things falling at 9.8 meters per second squared. That doesn't happen.
For you to say, oh, it's
and if a leaf doesn't fall at 9.8 meters per second squared.
No, it's a fact. We can take an
fact. It's calculation. Calculation is not a measurement. Calculation is mathematics, not measurement.
Look, I can take a ball 1,000 miles or 1,000 feet. And I could drop that ball, and using the rate that we know things fall from, which is not
the object you drop it.
I can tell you exactly when that ball will hit. It's a measurement. That is not
Please, one at a time. Please, one at a time. I can't even hear you.
That's a factual measurement. You cannot. For you to say that is to say, oh well, my car is 14 foot long, but it doesn't exist.
No, that's not what I said. That's misrepresenting my argument, Don.
It's not a misrepresentation. I can give you an observable. I can, just like Newton did. He saw something fall. He said, I wonder why that fell down and not up. And he figured it out that there is an acceleration that pulls things to the ground at 9.8 meters per second squared. It's not a calculation. It's a fact. We can take something up 1,000, something up 100 feet, drop it. Come out exactly when
it's not measurement. You can't see objects of different densities falling at, both of them fall at exactly the same rate of 9.8 meters per second squared. That doesn't happen.
I think somebody hang on, wait a minute. I think somebody mentioned in the chat before a helium balloon.
Yeah, I know that. Yeah.
What is buoyancy? That's buoyancy.
Now, you asked for an explanation, an alternative explanation to gravity, right?
Now, you can't density.
First of all, we're going to have to talk about weight. You said that density is caused by gravity. Density is not caused by gravity. Density is caused by the amount of matter within a body.
Let's not get out of the gravity. You haven't explained what it is. What is that force that...
I'm going to give an explanation in a minute, but first we're going to talk about the word weight. Do you believe that weight is caused by gravity?
Weight is caused by gravity, absolutely.
Yeah. Now, if I said to you, an object's weight is defined by its inherent density within its volume, could you debunk that? Want me to say it again?
Yeah, I can debunk that because you can't give me a weight on that. Give me a weight of something. Give me a weight of a 4 by 4 inch square.
No,
straight cube.
No, don't avoid the question. Answer the question. Right. I asked you. Right. I said,
calculate into that.
Right. I said to you, an object's weight is defined by its inherent density within its volume. Right. I asked you, can you debunk that? And you said yes. Right.
Yes.
Then debunk it.
I know you have to explain the weight.
Ask me to do something. You said you could debunk it, so it's up to you to do it.
Yeah. You're not using the whole formula. You have not
formula. What I just said there completely excludes any necessity of gravity.
Okay, listen. So Brian, can you so just because I'm sure that at some point that Don may want to mirror this on his own channel, so for his own audience to sort of understand this, if you could clarify specifically the question that you want Don to answer or to try and debunk. And then if you'll then give Don the floor to actually give a chance to respond without interrupting, if you could try and sort of like let it a back and forth for now, because this constant interrupting, it cuts everything out. Okay. So go ahead, Brian. That's
the problem. Okay, I asked Don, could he debunk what I said? And then he said yes.
So what did you say? What did you say?
And then I said to Don, I said, an object's weight is defined by its inherent density within its volume. I said, can you debunk that? And he laughed and he said, yes. And then he started asking me to do something. It's not up to me to do something. He said he could debunk what I said.
Okay, I get that. So, Don, if you could, you've got a couple of minutes here. If you just want to try and debunk what Brian's just said, and then perhaps we can move on from that, because Brian's got his bee in his bonnet about this particular part.
Okay, well, here's the debunk. He can't give me a weight of that object because without the pull of gravity and in with his figures, he's not going to get the weight of that object. Period.
I didn't give you a calculation, Don.
You just said if I put you saying a certain amount of mass inside of a certain volume, then give me that volume and give me that that how much mass is in a certain amount of volume.
That's a measurement of the overall. I didn't give you a measurement or a calculation. I gave you a definition. I asked you to debunk that definition, and you said, and then you asked me to do something for you
without using gravity.
It's up to you to do it. It's not up to me to debunk it for you.
No, I'm not. I'm telling you that you can't get the weight of that object without applying gravity, the measurement of gravity to that equation. That's what I'm saying to you.
I said to you a minute ago, takes gravity out of the equation completely. Because it debunks any reason for gravity. Because an object's weight is defined by its inherent density within its volume.
Then I oppose the question to you, Brian.
No, but you said you could debunk it.
Stop. If I have a cube that's
free to do something.
Every direction, give me its weight. What should it weigh,
talking
Brian?
about a specific object. It's a definition of weight. A definition of weight itself.
Measurement of, you're not giving me a measurement of its mass or volume. So how can I give?
I'm not talking about any particular object. We were talking about weight. You agreed that you believe that weight is caused by gravity. Is that true? You said that a few minutes ago. You believe that weight is caused by gravity. Yes.
Yeah, the weight is a measurement, and it's measured off the pull of gravity on the object.
Weight is measured off of pressure, a downward linear pressure on a scales. That's what measures weight. A downward linear pressure on a scales. But I give you a definition of weight, and you said you could debunk it. But you haven't put that. You put the question back to me.
What do you think? How do you think they calculate a fucking bathroom scale, Brian?
How did they calculate?
How do you think it's the weight into account?
What do you mean? How do they calculate it? They don't take gravity into account.
And your volume.
How much? It's how much weight that the inherent density. It's how much weight is within. Let's say you stand on the bathroom scales. It's how much weight is within your whole body that's pressing down on that scales.
Gravity. That's why.
Gravity. There's no gravity.
Yes, there is. It's inside of it.
Explain to me then. Explain to me. Right,
okay, Brian. It's included
in my definition. So I'm asking, explain why methane, and other gases go up the way.
How do you calibrate a scale? That would be my
helium and hydrogen rise.
That's because
they rise. I can explain to you why things fall and why things rise. I can give real world explanations that people can contest.
You have to have a vector
for any kind of effect or force from space to be involved.
Vector. Does density have a vector, Brian? Does it? Does density have a vector? Just answer the question.
Weight is a vector. Now I asked a question and you've avoided answering it now.
Force. That's my question to you.
How come, right, methane, helium, and hydrogen all rise through the air?
Okay, so and that's because they're lighter than the air, Brian.
Exactly.
That's not, sir.
Exactly.
That's
less density.
That's just me.
Medium of air. Anything of less density will rise.
Brian, it works the same way water does, man. What don't you understand about that?
There are two different mediums.
The water. The water. It's an upthrust. It's called upthrust. That's a term for point.
Okay. Listen, the audience is struggling really to hear any of you when you're talking over each other like this. For some reason, it cuts out. Well, it doesn't cut out both of you, but it just turns it into just one jumble of nothingness. So if you could try just I know it's a very heated subject, but if you could just please try to just do one question, one answer, a question and an answer. You guys can do this. You know the score.
Well, I'm trying to be civil, but
I'm trying to be you. But you have hypothetical question where if I can put some density into a volume, what's its weight? How the fuck do I know? I can't.
I didn't ask you that. Did you even? That tells me you didn't even listen to what I said.
Hey, let me finish.
Even listen.
I can give you the answer to that unless
I said it about 4 times. Can you say it back to me verbatim?
What? Can I say what?
What I said to you. Can you say it back to me verbatim, or did you not listen at all?
Basically, you're asking me if you just use density and volume, can I get the weight? That's what you're asking me.
No, I gave you a definition of weight. I gave you a definition of weight. I said to you, I'd say it again. I said an object's weight is defined by its inherent density within its volume. And I asked you, could you debunk that? You laughed and said yes. Then you continued to not debunk it and start asking me to debunk it for you, and then started throwing questions at me. You said you could debunk it, but then you didn't do that.
Okay, well, I just debunk it with one word. Well, with a few words. It doesn't have a weight until you apply the force of gravity, 9.8 meters per second squared. It doesn't have a weight, Brian. You can't get around that fact. All your words have.
Relative density equilibrium completely explains the whole lot of weight. There was no need.
Brian, could you just let Bob finish his point there? Go on.
You can't get around the fact that we determine weight from the pull of gravity, Brian. You can't get around that fact. Okay? It is completely and totally dependent on how much force is how much gravity pulls on the mass that's there. You can't get around that fact. You can't give me the weight of anything without applying gravity. You can't.
Yeah,
Tell me.
Okay, so Brian, can you let Brian respond, please?
Yeah, well, wait. I'll give him a specific, but see, he won't give me a specific thing. I'll give you a specific question, Brian. I have a cube that's 4 by 4.
Questions, Don. You still didn't confirm that you listened to what I said.
Okay, right. I'm going to tell you what I need to do here. I need to sort of like jump in and just say, okay, let's start this from scratch and say, don't ask a question, and then Brian answer that one question, and then Brian, I would like you then, even if it's a question that you asked 10 minutes ago, to then go back to that question and try to re-establish that particular question, and Don can answer that. Please, if you would just try and sort of like get back to these questions that you both have for each other. So Don, please, if you could just ask your first question and then let Brian respond, and don't interrupt, please.
Mass is a measurement of the amount of a matter that something contains. I'm sure we both agree with that. All right. Now, weight is the measurement of the pull of gravity on that object, Brian. So now I'm going to ask you again. How can you just use density and volume and give me a weight? Go.
You use the word mass, right? Mass is a description, but mass is also a mole, which is a calculation. Okay. The word mass is always connected with gravity, right? The word mass is a completely unnecessary word, right? There's no need for the word mass other than in the belief of gravity, right?
Oh my God.
There is no detection of any kind, right, in any way, shape, or form, ever proven for gravity. There is no proof whatsoever.
Do you understand, Brian? Density is mass volume. That's what density is mass per unit volume, dude. We're talking about the same fucking thing, dude.
Density is the amount of matter within a volume. No need for the word mass.
The word salad don't work on me. You can try to change it all you want, but density is mass per unit volume, man. You can't get away from
the amount of matter within that volume. That's another way of defining it.
That is just exactly what I said. I just said density is mass per unit volume. You just said the same thing I did, just with different words, Brian.
Yeah, I don't use the word mass because the word mass connects to gravity. That's why I don't use that word.
Density is the amount of shit in a bowl. How's that sound?
If you want to put it that way.
Mass can be anything, Brian. You're getting hung up on a word, brother. Fuck what mass means to you. Mass doesn't mean nothing but how much anything.
I said that to start off. Words have meaning.
Is, man. You're getting hung up on a word, dude. And a word means nothing other than the amount of something in something. It still means the same thing, no matter what you say or what I say. We're still saying the same.
And the word mass also connects to gravity.
My God, dude. I'm sorry, but that's the reality we live in, brother. It is. Oh. You can't give me something that substitutes
reality that you live in, Don, not my reality.
Well, then give me something.
I don't live in that reality.
Tell me why things.
You believe that gravity is a force or an effect pulling things down to the center of a sphere. That's not my reality.
Well, then what's your reality, Brian?
Here's the question. What is your proof of gravity? Why would you prove gravity?
When I drop something, it falls. Not only does it fall, it accelerates, Brian.
Don, I can explain that relative to the equilibrium. That's not proof of gravity.
Let me finish, Brian.
It means that it's nothing else. The proof of something, Don, means that there is no other explanation. That's when something is proven.
Tell me something. What is force, Brian? Tell me what force is.
Force? I don't know how to define force.
Force is mass times acceleration, Brian.
Yeah, that's the way. It's
okay, how about this? It's a baseball times the acceleration. I won't even use mass.
You could also say matter times acceleration.
Brian, get off mass, man. I'm not calling it mass now. I'm in an airplane, or I'm in a fucking helicopter, and I drop a baseball.
Yeah.
And it falls to earth.
Yeah.
It don't just fall, Brian.
Up there in the first place.
Brian, it doesn't just fall, brother. it accelerates. It gains speed as it goes.
You're saying it gains speed the closer it gets to Earth.
For it to do that, there has to be force.
That's not true.
So
Has to be a.
hang on, wait a minute. I know you just said that there needs to be a force there. Could I just intersect for just 1 second? Would you agree that it is now commonly known that gravity is no longer a force per se?
I will agree that it's never been a force. It's been applied in physics as a force. It has been an apparent force. It can be treated, Ranty, as a force. That's just something that you guys have to get over. It is, and it can, and it does. When you talk about vectors and things dropping, if it was to just drop and it was to never change its speed, then we would say, oh, there's no force there. It's just falling through denser till it reaches its dense.
Okay, so just to clarify, so the analogy with dropping the baseball bat out of a plane that required a force to pull it to accelerate it, but gravity isn't a force.
If we at force, there has to be a force to cause it to accelerate. There's no hope for anybody that doesn't believe that, because that is a fundamental fact.
You stated there a few minutes ago that things can accelerate and continue to accelerate towards Earth when they're dropped from a height. That's not true.
No, I don't want to hear the Baumgartner shit. There's something called terminal velocity.
No. Baumgartner, right, slowed down the closer we got to Earth because the atmosphere got denser.
It's called, Brian, that's called terminal velocity.
Became denser, so he slowed down in his fall. That is true.
Brian. So he became denser.
Yeah, no. The medium he fell through became denser as he fell towards Earth.
More resistance pushing on him, Brian. What part of that don't you get?
No, it's falling through something. It's not more resistance pushing on him. It's that he has more structural support than he did have when he was higher.
It's called he had more air molecules pushing against.
There was more structural support for his density within the density of the medium when he got closer. The closer we got, there was more structural support within the density of air for him. That's why he slowed down.
Do you understand, though, that that's a force, though? That was a force.
No force pushing him.
That was a force acting in the opposite.
But how come helium balloons go up then?
I just told you, boy.
Hydrogen goes up. How come methane goes up? How come hot air goes up? How come anything that's lighter, that's less dense than air goes up, and everything that's more dense than air falls down?
Buoyancy.
It doesn't explain that.
Yes, it does. Buoyancy explains that, Brian. Gas
proven gravity.
Exactly like liquid. Yeah. Our atmosphere is treated basically like a liquid, Brian.
Well, no, it's not. No, it is not. Our atmosphere is gas. It is not like a liquid. Liquid has bonded molecules. Gas has unbonded molecules. Not the same. Two different fluids.
Gas as a liquid. Basically.
No, two different fluids, right? Two different fluids. Liquid, right, is incompressible. Right?
Oh
right? Gas is compressible.
I'm just talking about
fluid. Gas is a compressible fluid. You can compress gas and bring up the pressure by compressing it. You can't do that.
I'm talking about in layman's terms, Brian. There's buoyancy in the air, just like there's buoyancy in the water, Brian. It's the same thing, man. You have molecules in the air. Like when you said, it's for example, like when I read your comment saying that, oh, gravity's fake because if gravity was real, we would be crushed. That's stupid.
That's not what I said. That wasn't. I didn't use the word gravity at all.
The air molecule would crush it.
My point was, if you want to know about it, because you didn't know, that was the thing about it. You didn't know. You got angry. You looked for a debate of me, but you didn't even know what I was answering to. What I was answering to is people were trying to say that the atmosphere, right, has a linear downward weight like water does, like an ocean does, and it doesn't have. The atmosphere has pressure, gas pressure, in all directions. One of those directions is down, right? There was other people in those comments trying to insert what's known as hydrostatic pressure, right, and saying that the atmosphere had hydrostatic pressure, which it does not. It cannot have, as the atmosphere is gas, and gas cannot have hydrostatic pressure. Only an incompressible fluid, which is liquids, can have hydrostatic pressure. That's why submarines have what's known as a crush depth when in the oceans because of hydrostatic pressure. The pressure, the static pressure down the way because of the amount of volume and weight of the liquid, of the water, that causes hydrostatic pressure. And the fact that it's still, because water has bonded molecules, it means there is movement within the molecules, but they're basically like held together by hydrogen bonds, which are like chains, right? So the molecules are held together by hydrogen bonds, which are like chains, which hold the whole thing together. So consequently, no water molecule moves around independently, but every gas molecule moves around independently. So my argument online was that there wasn't any hydrostatic pressure in the atmosphere because it wasn't possible, because the atmosphere was gases. That was my argument, and you took it up wrong, and you took it wrong, and you started coming at me with stuff.
But the pressure is still the pressure, and it's still
pressure. No, there's pressure. There's gas pressure in the atmosphere.
The pressure in the air is still 14.7 psi, Brian. Period.
At ground level, that's what it's supposed to be. Yeah, it's supposed to be
measurable. Yeah. It's what a barometer's for. It's measurable.
That's right. No, I don't disagree with that.
Okay.
I don't disagree with that. But I think what happened
but do you also know that we have in our bodies exert an outward pressure? Do you know that?
Yeah, that matches the pressure internally matches the pressure outside.
Exactly.
Yeah, that's right.
So therefore, why would it be crushed?
You know what I'm saying? When you take a bottle up high on a mountain, there's just something someone even said to me recently. When you just as an example, it's a good example. When you take a bottle up high on a mountain and you open up the top, an empty bottle, and you allow it to equalize with the pressure up there, and you put the top back on it, when you bring it back down the mountain, that bottle will start to crush because the internal pressure is not matching the external pressure.
I mean, it's the same reason our ears pop when we go on a plane. I mean, it's just that's just basic. But that's all I'm saying is that it's treated no different. There's buoyancy in our atmosphere, just like there's buoyancy in the water. And helium is just more buoyant than air.
I agree that buoyancy is in our atmosphere and in our oceans. Now, it's different because the medium is different. So an airplane is designed to take advantage of the buoyancy of our atmosphere, whereas a ship is designed to take advantage of the buoyancy of our oceans. You know, it's still buoyancy. It's still, if you want to call it buoyancy, it's still a type of buoyancy. I term it different than buoyancy. I term it volume area design and displacement. Right. Well, volume area design and displacement. It works that way. It works the same for airplanes and for ships. Let's just say.
Did you say an airplane uses buoyancy?
Yeah, they use the buoyancy of the air. They're using the air.
Pretty much using thrust and lift, man. I mean.
Yeah, but do you know that airplanes are designed, right, to push the air underneath it, right, to keep the lift,
to give it lift.
Yeah, it's designed like that. But that's using that's using buoyancy. That's using the buoyancy of the medium of air. They're using that's what it's doing. It's using the buoyancy of the medium of air. By doing that, that's why the airplanes always fly with their nose 1 to 3 degrees up, and that's the reason.
But the bottom line is,
take the air in from the front and bring it underneath it.
The bottom line is this: you cannot replace density with gravity with density, man. It doesn't work.
I'm not replacing. It's just gravity doesn't exist. There is no evidence for gravity.
Why?
How would you like for you to give me proof of gravity? It means there's no other explanation. But how do you give me proof of gravity?
And then, Brian, give me a reason why things accelerate down towards the center of Earth. Explain that.
Things don't accelerate at 9.8 meters per second squared. That's a calculation, not a measurement. I've told you that.
Brian, how do you
calculation? A broad calculation, not a measurement.
It is a fact. It's a measurement,
it's a calculation, Don. It's not a measurement. A calculation is not a measurement.
It's not a measurement. So I can't go up in a helicopter 500 feet in the air and using the pull of gravity, the 9.8 meters per second squared, drop that ball and give you a time and exactly when that ball is going to hit the ground. I can't do that.
It depends on the density of the object.
Shit, where I'm at.
The object is going to change how fast it falls.
For
Even
you
in a vacuum chamber, an object's density will change how fast it falls. It just you just have to do it in slow motion to see it.
For density to take the place of gravity, you have to explain why things fall. Because I can do the same thing.
Explain it to you, but you're not listening, Don. The same way as you didn't listen earlier. I told you, everything that's more dense than air, than the medium of air, will fall through it. Everything that's less dense than the medium of air will rise through it.
Brian, I can do the same thing in a vacuum, and they still fall.
Yeah,
so you can't.
Things in vacuums fall. Well, 1 second. Right. How do you know? 1 second. Wait. 1 second. 1 second. If you take away all the atmosphere in a vacuum, right? If you take away all the atmosphere in a vacuum, right, and you pump helium into that vacuum chamber, then it's not a vacuum chamber anymore.
Did I say that? Did I say?
Well, you said you can make everything fall in a vacuum. That's what you said.
So for you to explain density to work, it has to fall.
Explain it. I can give physical demonstrations of it, Don.
Brian, it does. You have to. You can't explain it by saying, "Well, I'm going to take out the atmosphere and put helium in there." That does not explain it. You got to tell me what
you said to me. You said to me things. You can make everything fall in a vacuum, and I said, right. I said if you put helium, if you take a vacuum and put helium into it when it's after being when the vacuum is being on, you put helium into it. What the helium will do is fill the available volume.
Brian, is that a vacuum?
What, Don?
Answer the question. No word salad.
I didn't hear you, Don. I didn't hear. You're talking every time you're asking me questions, and every time I talk, you continually won't be quiet. You continually won't shut up and leave me speak. It's not my fault. If you want to hear what I'm saying, then you got to be quiet enough to hear it.
All right. Okay. Well, here's my question one more time. I have a vacuum. What is the definition of a vacuum? It means void, right? There's no air in there. There's nothing in there. So no helium, Brian. No butane. No nothing. It's a vacuum. Right. Because once the minute you start pumping helium in that vacuum, it is no longer a vacuum.
Yeah, that's what I said.
Oh my God.
That's exactly what I said. I said as soon as you put helium into the vacuum, it's not a vacuum anymore.
So then why would you use that as a reference of shit falling? I asked you a question.
You can make everything fall in a vacuum. That's what you said.
No, I said explain why shit still falls down in a vacuum.
Yeah, if it's density. It doesn't matter. Objects of density are still going to fall. Anything with density is still going to fall. There's no. Do you realize when you take away the atmosphere? 1 second, let me explain something here. When you take away the atmosphere, right, in when a vacuum chamber takes away the atmosphere, right, what it does is it takes away all structural support of all kinds, right. So anything is going to fall in that. But if you put a gas in that, it won't be a vacuum anymore because the gas will fill the available volume. It won't be a vacuum anymore. But anything you put into a vacuum will fall, right. It's nothing to do. Density is not connected to vacuum or no vacuum. It doesn't matter whether it's a vacuum or not. An object density is not going to change just because it's a vacuum.
I'm just asking you, if I take a baseball inside of a vacuum chamber that's 10 feet tall, and I start that ball off dead center in that vacuum, and I let it go, why is it falling, Brian? Why doesn't it go up? Why doesn't it go side to side, Brian?
Because of density.
Down.
Density will cause it to fall.
Density does not have a force. Density does not pull that down. You have to explain.
Will cause it to fall.
If it's seeking its density layer, why does it?
It will fall. Things with density will fall. That's what will happen.
That don't make sense, Brian. It don't make no sense, man.
It does. What other evidence have you got for it falling? What is it that you have evidence for as to why it falls? What is your evidence to support it?
There's a force applied. There's acceleration, Brian. And you can't have an acceleration
without a different explanation.
No, you have to come up with it. I have an explanation. It's called gravity.
What is your explanation? What is your explanation?
And why that ball doesn't go up trying to find its density layer, but it goes down. What's making it down and not up, Brian?
What is your explanation, Don?
Gravity, Brian.
Prove gravity for me.
There's a downward.
Proving gravity. I'm to prove gravity because you keep on inserting it. So what is your proof?
Brian, I just did.
You didn't prove gravity.
Yes,
you didn't
I did.
prove gravity.
Oh,
No, you didn't prove
well,
gravity. You did not prove gravity. You did not prove gravity. You inserted gravity into an example. You didn't prove gravity.
I proved that there's a downward acceleration.
You didn't prove there's a downward acceleration. That didn't happen. You didn't prove any of those things. You added them into your example.
What did you prove, Brian? You're just saying, oh, it just falls.
I can show you a physical demonstration of things falling in a vacuum.
Yeah, I can show you tons of them. Then they just fall, brother.
Okay, I'm going to show. One second. I'm going to show. 1 second now. I'm going to show a very short video. It's only like a couple of seconds long because of copyright infringement. Where is it there now?
You're not, but something falling. I need to know why it's falling down.
Show it. It's only less than 10 seconds long. I'll show you something here.
Okay, go ahead, man.
All right. As soon as I find it.
Oh my God.
I have to just find it here. Right. These are. I'm going to show you things of different elements. Right. Things that are made of different elements falling in a vacuum. Where is it gone? Jeez. There we go. Right. Now, I'm just going to share my screen, Randy. Okay. I take it that's okay.
That's fine, yeah. Fire away.
Okay. Now, you can see my screen, I take it, yeah?
I can.
Okay, let's make this big. Now, there is a longer version of this video out there, but I don't have it. And I can't share it because it's more than 10 seconds, so there might be a copyright strike. So this is different objects, different objects of different geez, the word has gone from me now. Elements falling in a vacuum. Right, watch. This is the reverse of it. Did you see that at the start? I'll show you again.
I don't see anything. What's going on? What is it?
It's after playing on to the next video, which I don't want it to do. Sorry, go back. No. There you go.
Are you about to just show me something?
See those things rising there, Don? I'll show it, right? See those things rising? I'll just go back, right?
I don't see. All I see is, okay, I see something going up. Okay. Right. What's your point?
That's things falling. That's actually in reverse. That's actually elements falling, right? Right. Elements, different elements, right? Of the same thing, falling in a vacuum. Different elements, right? Falling in a vacuum. That are falling at different. They're falling at different.
Thank you.
Due to their
gravity.
Due to their densities.
Thanks for showing me gravity. Appreciate it.
It's not gravity, Don. Right.
It is gravity.
You haven't proven gravity. You haven't given any proof of gravity. All you've done is insert gravity. You haven't given a proof of gravity.
Well, here we go. Here's something I want to ask you then. Do you believe in the laws of motion?
The laws of motion. Are you talking about Newton's laws of motion?
Absolutely.
I don't really. Do I believe in Newton's laws of motion? I heard that they were debunked. I heard they were debunked some years ago. Now, whether that's true or not, I don't know.
Well, they'll never
show you something now. 1 second now. Right. 1 second now. Right. This is going to be 37 seconds long. Right. Now, gravity. Can you see this screen here? Right. This is a gas. This is bromine, right? In a container, right? With a vacuum in a container, and they open the valve to allow the bromine to take away the barrier between the bromine and the vacuum, right? Now this is that ground level where gravity is supposed to be the strongest. Right? Watch
these bulbs, some bromine,
take this,
and in the other,
take the sound off, right?
There are some nice pictures of the moon.
Watch this. Watch this. Watch. As soon as he opens the valve for the vacuum, watch what happens.
I can't see anything.
It equalizes. So
I don't see what you're talking about.
Can you not see that yet? No.
No, it's kind of small, but I mean,
Well, that's. Oh, I'll go back again to give you another look at it. Right.
I mean, what you talking about? The guy in the suit?
Yeah. I just pause it. This guy has bromine right here in this end of the vase, and he has a barrier here and a vacuum pump connected to this end of the vase. He opens the barrier, right, and watch what the bromine does.
Well, it's going to fill the other side. What's that got to do with it?
Exactly. Right. Now, he's going to fill the other side, right? Now, your original assertion of gravity, right? There you go. Your original assertion of gravity, right? The first assertion you made was that it was keeping the atmosphere connected to the Earth. Now, if it's keeping the atmosphere connected to the Earth, right? How come that happens?
How does that happen?
Yeah.
Because do you know what pressure is?
I know exactly what pressure is. How come that is happening? How come that, more to the point, how come that doesn't happen? Because
that's because gravity.
Basically, what you're saying, Don, is that gravity will overcome entropy. Now, gravity 10 times over could not overcome entropy. Right? Even if gravity is real, I have zero belief in that. Gravity cannot overcome entropy, Don.
Right? You don't even know what entropy is.
We have that vacuum is very, very weak in comparison to what we're supposed to have. It's supposed to be out in what's supposed to be outer space, which is supposed to be 10 to the minus 17 torr, right? That's what we're supposed to be out in the outer space. So if we had an atmosphere next to a vacuum of that power, how come the atmosphere is not equalizing into the available volume?
Is that a negative or a positive number?
Sorry?
10 to the negative 17 torr, is that a positive or negative?
Not negative, minus, 10 to the minus.
Right. Is that a negative or a positive number?
It's minus. Not negative or positive.
Number? What is it?
It's a minus. It's minus. On the torr scale, is plus. Anything above 1 on the torr scale is plus torr. Anything from 1 down to 0 is minus torr.
You can't have minus torr.
You can. That's how it's from 1 down to 0 is minus torr. You can't have below 0. 1 down to 0.
So then you're saying that. Wait a minute, stop. So then you're saying 10 to the negative 17 torr is a negative number.
No, I didn't say negative. I said minus. I never say negative. I said minus. Never said negative. Right? Okay. You're misrepresenting. You have to listen. I said minus. You said negative, not me.
What does minus mean?
It means that anything, as soon as it goes into the minus values, the torr minus values in torr, then it's a vacuum. That's what that means. 10 to the minus 17 torr. It means that it's the most powerful vacuum we could probably get on Earth that we can make is probably 10 to the minus 10 or something like that.
But there is negative torr. We understand that. You do understand that there's no negative torr.
I didn't say negative. I said minus.
Oh, all that aside, do you even know what entropy is?
Yes. I know enough about entropy, John, to know that entropy would not be overcome by gravity in any way, shape, or form. Even gravity 10 times over cannot overcome entropy. It can't happen.
So we're talking about thermodynamics now, right?
I know that. I know enough that entropy cannot be overcome by gravity.
Okay. Well, all entropy is the measure of the amount of energy that's no longer available to do work. That's what entropy is. In other words, there's
entropy when the gas equalizes into an available volume. That's entropy. There's loads of different. A rotting body is entropy. That's also entropy, right? There's loads of different. There's like hot going to cold is entropy. High pressure to low pressure is entropy.
Second law of thermodynamics is basically just the quality of energy. I mean, I hear you guys misquote thermodynamics all the time. It's all the second law of thermodynamics states.
The natural law of entropy states, right, that high pressure will always go to low and hot will always go to cold. Right.
States the second law of entropy states that the thermodynamics states that As energy is transformed or transferred, more and more of it's wasted. It can never decrease over time in an isolated system. Earth is not an isolated system. We get energy from the sun, and we radiate energy back into space. Earth is not an isolated system. Therefore, the second law of thermodynamics does not apply.
What is Earth?
I just told you.
It's an isolated system, Don.
It is not.
It's an isolated system. There is a system. The isolated system is only something within science.
Earth is a closed system.
Is Earth an open or closed system?
Earth is not an isolated system. It's a closed system, but it's not an isolated system. I suggest you look up the difference between a closed system and an isolated system.
No.
We still radiate.
No, I'm asking you a question. Right, you define an isolated system for me then, Don.
Hang on, one thing. I just want to clarify. Hold on. I just want to clarify one thing, please, just before you go any further. The mainstream globers in this debate right now, currently, the ones that are on the scene most of the time that are debating us flat earthers, are leaning towards an isolated system now. Just wanted to point that out.
Yeah, nonsense.
Earth's isolated. That's what I said.
Don, please define. Please define for me what an isolated system, a closed system, and an open system are. Give me the 3 definitions for them, please.
Okay, an isolated system. We're an isolated system. The reason we're an isolated system.
We're not an isolated system, Don. That's incorrect. First of all, I want to say, 1 second.
That's wrong.
The people in chat saying I said the word negative. I did not. I said -4. Never said negative. Listen back. Stop wasting my time. Listen back and prove your assertion. Don, right? We are not in an isolated system because there's no such thing as an isolated system. We're either an open or a closed system.
Earth isn't an isolated
system. Cannot transfer matter or energy.
At the beginning, I said Earth is not an isolated system. Earth is a closed system. Sorry, I got them confused. You fucking got me confused.
You are correct.
Earth is a closed system. It's not a system.
That means that you're not on a spinning globe, Don.
Brian.
System. The spinning globe is an open system.
It's a closed system. It's not an isolated system.
Don. No, it's not a closed system. If it's a closed system, then how come you have space missions on the globe?
Oh my fucking God, dude.
How do you have space missions? How do you transfer matter in a closed system? Please explain that.
We get heat from the sun.
No. How do you transfer matter, right? How do you transfer matter, right, in a closed system?
We cycle.
I'm going to define these things for you, okay? An isolated system, right, can't transfer matter or energy. A closed system can only transfer energy, and an open system can transfer matter and energy, okay? In a closed system, you can't transfer matter. Now, I'm sure space shuttles and all this other stuff, right, is open matter. How do you transfer matter in a closed system?
Experience the biosphere. You are fucking wrong. All right,
you're wrong, Don. You are absolutely wrong. A closed system, right? A closed system can't transfer matter. So if you're claiming to live on a globe and you're claiming it's a closed system, then you're wrong.
To you is you look into what a closed fucking system is,
I know,
because we are a closed.
Yeah, I know. Yeah, we are a closed system. It's called flat Earth. Flat Earth is a closed system. Yeah, enclosed. All right, so we can't transfer matter, but we can't transfer energy. Closed system, flat Earth, enclosed.
You're wrong.
No,
you're wrong.
You're wrong. Right, you're wrong.
No, I'm not wrong.
Globe, right, and you're trying to claim. First, you're trying to claim a closed system, right?
Because that's what we live in.
It's an open system, right? Without any barrier next to a vacuum. That's an open system. Where supposedly you said earlier people went to the moon, right? You can't do that on a closed system.
Just because you don't understand. Just because you don't understand that a closed system doesn't mean it's wrong. Sorry that you have a misconception.
I was able to give the definitions. You weren't able to give the definitions. I asked you to define it, and you just kept on asserting. This is a case of you just assert. That's all that's going on here. You're not giving me. You didn't give me the definitions.
Okay, here's by definition, a closed system is a system in which the only thing that can be transferred, Brian, with the surroundings is energy. That's what a fucking closed system is. You don't know. Can we get somebody in here that knows what the fuck they're talking about? Because this dude don't know.
I know what I'm talking about. Yes,
shit.
I agree. But you're trying to fight for a globe, right? The globe is an closed system.
You don't even know what the system is, Brian. Sorry? You think that because I'm saying we're in a closed system that somehow we have some kind of just magic fucking...
We're a closed system. You're correct about that, but it's not a globe, because if we were on a globe, it would be an open system.
You're wrong.
No, I'm correct. You're incorrect.
Wrong and I'll give you the thing you said to me. Just that you're wrong and move on, brother. Earth is system.
You weren't able to find the three systems.
I just gave you the definition of a fucking...
You eventually gave me the definition of a closed system, but that's talking about a flat Earth. Right? You can't have... The globe is not a closed system. It's an open system. It has an atmosphere outside of it that's right next to a vacuum without any barriers.
Oh, wait a minute. Do you think that because I'm saying closed system, that means we have a dome? That's what you think.
It means we're enclosed. Enclosed. We can't exchange matter. In your belief, Don, of a globe, right, you exchange matter with the outside. You believe you went to the moon, don't you?
System means, dude. Oh my God, dude. Oh my God.
You believe they went to the moon. That's supposedly 250,000 miles away, in your belief.
No, it's a fact. It's a fact.
Do you believe they went to the moon? That's all. Just a yes or no. That's all I'm asking you. Do you believe they went to the moon?
We absolutely did, and there's no way you can...
How can you live in a closed system then? How can you believe that and then also believe you're in a closed system?
Like I said, just because you don't understand what a closed system is...
I understand perfectly what a closed system is. I was able to define isolated, closed and open for you. You weren't able to do that for me. You got the closed and isolated mixed up in the first place.
It means that just because you don't understand it doesn't make it wrong. I'm sorry that you don't understand.
You're wrong. You're incorrect. You're incorrect. You believe, because your whole belief system is a contradiction. You believe they went to the moon, which is 240,000 miles away from Earth, right? In your belief, right? And you also believe that Earth is a closed system. You can't have it two ways. It's either an open system and you went to the moon, or it's a closed system and you didn't go. It's simple as.
Oh my God.
I'm just being honest. It is what it is.
Wrong. You're just wrong.
Right. I'm correct. An open system, you can transfer matter and energy, right? Which is what the globe is. A closed system, you can only transfer energy. So how could you go to the moon, which is outside of our system, in that belief, in the belief of the globe? How can you go to the moon, which is outside of our system, in the globe belief, right? Go out there in things that are made of matter, with people in there who are matter, right? When you can't have an exchange of matter in a closed system. That is an open system.
Listen, you have a fucking change. You see, that's how much you don't even know. I just gave you the definition of a closed system that said that we do transfer fucking heat and matter. You're just a fucking idiot. You're just an idiot, dude. Listen, explain it one more time. If you just zip it for 2 seconds, I'm going to explain to you why, even though we went to the moon, Brian, it's still a closed system. Okay? Here's why, Brian.
Yes.
It is. All right. It's a closed system. And all that means is that all the matter inside the Earth's atmosphere is kept inside as long, Brian, as long as it follows Earth's physical laws. Okay? You following me, Brian? It follows our physical laws. Only when the matter breaks those laws and leaves Earth, like for instance,
how do you bring matter out of a closed system, though?
Fucking rocket and
anymore, but it's wrong. That's it. I'm not listening to it. I'm not listening to your nonsense explanation. You can't explain that one. You're wrong. You're scientifically correct. You're scientifically wrong. End of story, Don.
You are. You are.
No,
you are. You
not,
Brian. My question to you is:
not incorrect at all.
Gravity will destroy people on Earth.
Science agrees.
So heavy. And read a book. The Earth is a closed system, brother. Sorry, you can't accept that.
It is a closed system, 100%.
Right.
It's a flat, stationary, enclosed system. That's what
you're Yep, we are. We're in a closed system.
Dynamic system, Don. Be more correct. Be more correct about it. It's a closed dynamic system. And no matter
they broke the laws of our physical Earth and broke away from that and went to the moon. There's a difference. See, you don't understand. You think you're one track minded, and you think because I'm saying closed, nothing can leave our Earth. You're wrong.
Closed system, because it's not a closed system. Then, if you can leave, it's an open system.
You don't even know what the fuck you're talking about, right?
Yes, I do.
You don't know what you're talking about.
What's wrong here? What's wrong here is your pride is getting in the way of accepting that you were wrong.
By definition, a closed system is a system in which the only thing that can be transferred with its surroundings is energy. Got it?
Correct.
A sealed box.
You are correct that it's a closed system that you can leave. You can't. It's a closed system. You're correct about that. But you're incorrect in thinking you can leave it.
If it's turned up in the room, then the box will get hotter. Brian, you don't know what you're talking about. You don't.
You're saying that we're living in a closed system and we also went to the moon. You can't stay.
You have
a contradiction.
Head.
If we went to the moon, Don, then we're in an open system.
For size, and that we live in a closed system because we have a dome. You keep believing in that, but
I never said we had a dome.
No,
I said we have to have a container. It might be a dome, but I don't know.
Where's it at?
That's misrepresented.
Show me a video of a rocket bouncing off the supposed dome.
I don't have any video of rockets bouncing off of domes.
There's no dome.
I don't have a video of that.
Can't show me a video of a sun that changes dramatically in angular size throughout a day.
Bromine, right, of the gas bromine equalizing into a vacuum immediately.
Wow, so you showed me the pressurization of gas. That means
necessary antecedents, right, of gas pressure. Or gas pressure.
So you have gas pressure.
You cannot have gas pressure without a container on. That's impossible. In an atmosphere system, like your globe,
I see.
Right, the atmosphere would equalize into space because you think cannot overcome gravity, and that's that.
Right. Like I said, you think gas and atmospheric pressure are the same.
Gas are not. They are. What is the atmosphere made of, Don?
They're not.
Made of gas?
It doesn't matter what it could be made out of shit. It's not.
It's not. No, it's not. No, no nonsense, Don. No nonsense. Let's stay on point. Is the atmosphere made of gas?
Doesn't matter. It's made of gas. Does that matter?
Is the atmosphere made of gas?
It doesn't matter. It doesn't matter, Brian.
You said a minute ago that I think the gas pressure, gas and the atmosphere are the same. I don't think it doesn't matter.
The
atmosphere is
trying to compare
gases, Don.
With the gas inside of the propane tank, and it doesn't work like that.
That is that.
Away from it,
these are the facts. Don't take the facts, Don. Can't be refuted.
You don't know what a closed system means. Yes, you don't know what a closed system means. You can't explain why the sun doesn't change in angular size through the day.
Again, Don. An isolated system. You can't transfer matter or energy. A closed system can transfer energy only, and an open system can transfer matter or energy.
I'm not going to argue with you. We're in a closed system, and we do exchange energy and matter outside of our Earth. Sorry that you don't understand that.
Sorry, you can't exchange matter in a closed system, Don.
It's awful funny that by definition, that's exactly what a fucking closed system does. But I guess you've created your own term for what a closed system is.
Exchange in a closed system, only in an open system.
Brian, right. No, that's an isolated system.
You can't have a closed system and be on a globe, and stick with globe belief with an atmosphere next to a vacuum without any solid barrier, and people going off to the moon that's 240,000 miles away from your system. You can't have these four. You can only have it either a closed or open system. If it's an open system, right? If you're claiming that they went to the moon, then that means your belief is that you live on an open system, right?
No, I don't.
If is that we live in a closed system.
You just don't know what this means. We live in a closed system, not an open one. You just don't know what that means. Yes, sorry, you don't.
Yes, I do.
No,
okay, guys, listen. I need some definitions here. I need some definitions of what you think a closed system and what an open system is. Please, thanks.
I know what a closed system is. I just gave him the fucking definition of a closed system. I don't need to repeat it for a third time, Randy.
He's right, Randy.
I don't
give me the definition of a closed system.
I just did.
closed system.
By
But
definition,
the state that matter
closed
leaves that
system,
system, which makes it
the
not
only
a system.
with the surroundings is energy. I just gave it to you.
Yourself, Dom. You're saying that a closed system, right, can only exchange energy and not matter, and then you're claiming that matter is leaving that closed system. Is that not an
there's no
matter?
Stop. Let me finish. There's always exceptions, Brian. Don't you know that? Okay, I told you that.
There isn't an exception.
Even Brian, and because virtually all matters, okay, it takes up space inside the Earth's atmosphere and kept inside as long as it follows Earth's physical laws. That's why when them three guys got in that fucking rocket and they blew off at insurmountable fucking speeds and they broke the...
You must believe it on an open system then. If you believe they went to the moon.
They went to the moon. There's no doubt about it.
You have to believe that's the way it is. You're contradicting yourself, Don. You're saying that we live in a closed system, then you're saying that matter, that spaceships...
Okay, listen, I've had to do it myself, so what I'm going to do is I'm going to bring up, for the audience, for you guys, to listen, pin your ears back. So I've typed in closed system, Earth science definition, right? So that's pretty concise, and it's essentially what you guys are arguing over. So this is the result that it brings up, the highlighted result. A closed system is a system in which only energy is transferred with its surroundings. An open system, however, is a system in which both energy and matter can transfer. The Earth is a closed system because only energy is naturally transferred outside the atmosphere. That is the definition.
Yeah, you can't transfer matter.
Said, and I don't care what you say, even though you may think Earth is closed, it doesn't matter as long as the only thing exchanging and leaving Earth and coming back in is energy, Brian, unless something follow the laws of Earth's physical laws, and then when it breaks the laws, it can leave Earth.
Natural laws.
Okay, so could I just ask a question here? So some of these gases, that do escape the Earth's, do escape. They go into space. Some of these gases, are they energy or are they a gas?
We lose oxygen. We lose hundreds of tons of oxygen in space every day.
So if the only thing that can transfer is the energy, then how is it a closed system?
How can we? How can it only be?
How can gas go into space and it be a closed system?
How can? Wait a minute. Stop. How can all things have mass, guys? Everything in the universe, even oxygen. So when we lose oxygen, that's still mass, right? Leaving Earth, right?
It doesn't mention mass. It mentions energy, though. That's the only thing I want. You wanted a definition, and it just speaks about energy, and you were quite concise with the definition for sticking to energy. And when we talk in terms of energy versus oxygen, they are two completely different things. So if the Earth is a closed system essentially just because of the energy issue, why is it still a closed system when we're talking about gases, predominantly things like oxygen that you've just referred to?
I never said that only energy leave. I never said that. I just use energy as an energy.
The definition says that.
But here's the thing.
Definition, that's a bit vague, that definition.
Even an atom has mass, Branny. And what I'm at is I say words
as matter, yes. So you're saying that we're in a closed system, yet all this matter that is gases is escaping the Earth every day, and people are going to space and space missions, and they're sending out rockets and coming back in and all the rest of it. Yet you're saying we're in a closed system. Yet a closed system cannot have an exchange of matter. That's my
space.
You're completely contradicting. You're contradicting yourself.
Kind of force to get there. Sorry, it breaks the physical laws of Earth. That's why
natural laws, they cannot be broken. You cannot break natural laws. Natural laws are natural for a reason. They are laws of nature. You cannot break them.
I can't argue with you, Brian. The facts are the facts. The facts are the fact that everything, including
natural laws. These are the facts.
Have to be able to leave Earth, and another mass not. Why would oxygen be able to leave our Earth? Escape?
Okay,
space.
okay, listen. I just clicked that definition, so I need to clarify something that somebody's pointed out on one of my subscribers has pointed out for me to read the first sentence. So just bear with me and pin your ears back on this. After completing this lesson, you'll understand why the Earth is a closed system inside the universe. Inside the universe, but listen, listen. This is the caveat. But an open system inside the Earth's atmosphere. You'll learn the one defining characteristic that makes a closed system. There we go.
Right.
So I'll just increase the size of that so that you know.
Wait a minute, Randy, before you continue. Let's be specific that you just said why Earth is considered a closed system. So I just want to go on. Now go ahead.
Yeah, and to clarify the definition, you'll understand why Earth is a closed system inside the universe, but an open system inside the Earth's atmosphere.
Right.
It says here, what do you think? By definition, a closed system is a system which the only thing that can be the only thing that it's gone. I think it's by definition a closed system is a system in which the only thing that can be transferred by its surroundings is energy. A sealed box is a perfect example of a closed system. I mean, what more do you need?
Brian, keep
the door on that they go away and come back in. It's not a system.
Don't cherry pick it. Read the whole fucking thing, because I'm on the exact fucking website you are. Read it all, Brian.
Oh, Ranty has that on screen. It's not. I didn't find this at all. Okay, read the rest. Right.
Don't stop.
Yeah. Oh. Okay, right. So, by definition, a closed system is a system in which the only thing that can be transferred with its surroundings is energy. A sealed box is a perfect example of a closed system. Nothing that's contained within it can come out, and nothing on the outside. It's after going off the screen, Ranty.
Oh, sorry, my mistake. My mistake. Sorry.
I'll have to go back again.
Outside can come in. However, for example, the heat is turned up in the box.
Leave Ranty put it back on. Leave Ranty put it back on, and I'll read it out.
The box itself, and eventually the content will heat up as well.
Screen, or do I have to find it?
This is because
it'll be up there in a couple of seconds. Don't worry.
I just want to read.
You may not think the Earth is a closed system. After all,
yes, I do. I know it's a closed system. I didn't say that. I never said it wasn't a closed system. Now stop misrepresenting my argument, because I never said that, pal. Right? I agree with you that it's a closed system. It's that you're saying it's a closed system, and then you're saying matter is leaving it. That's the definition of a closed system. Right. I'll read it again.
Right.
1 second.
You just want to keep talking.
Now I'm going to read it out. By definition, a closed system is a system in which the only thing that can be transferred with its surroundings is energy. A sealed box is a perfect example of a closed system. Nothing that's contained within it can come out, and nothing on the outside can come in. However, if, for example, the heat is turned up in room, right? Let's say they missed the in a room, the box is sitting in, or its surroundings, the box itself and eventually the contents inside will heat up as well. This is because heat is energy. Yeah.
Now read on. The Earth, right underneath that. You may not think the Earth is a closed box. After all, you hear of astronauts going into space and even walking on the moon. But in fact, it is closed because virtually all matter, things that have mass and take up space, as long as it follows Earth's physical laws. Only if matter breaks these laws does it leave Earth. Astronauts leaving Earth is an intentional act, and a difficult one at that. The space shuttle needs an incredible force of energy to break the law of gravity and exit Earth's atmosphere.
This is a contradiction to a closed system. Up above, when they say closed system, it says nothing can come in. Yet underneath, then they're trying to say Earth is a closed system, except for sometimes you can kind of leave it and kind of load of nonsense.
Wrong, Brian. Just say
it's a complete contradiction. The whole thing is a contradiction.
Say I was wrong. So you gotta say
I wasn't. I'm not wrong, Don. I'm correct.
It's absolutely
closed system. So when they speak about the Earth down here, they're actually speaking about an open system. They're trying to call it a closed system, but then they're saying, but sometimes things can leave. That's a lot of rubbish.
You're wrong, because the first definition of a closed system
says up here, nothing can leave it and nothing can come in. That's a closed system.
You're absolutely wrong, because your first definition of a closed system was nothing leaves it and nothing comes back.
No, my definition of a closed system was that matter leaves it and no matter comes in. Right? That's my definition. That only energy leaves, and only exchange of energy, no exchange of matter.
Well, I'm going to replay this video. I'm going to say, you said
definition of closed system.
Nothing.
So you're trying to make it out as if we can sometimes leave it. No, that makes it an open system, Don.
No, we can always leave.
It means the gas would fill the volume. It would equalize into what you believe to be the vacuum of space.
Treated as an open system. That's why. Because we can overcome gravity and leave our. That's what that means. That's all that means, is that we
can't break natural law. It's not possible to break natural laws. Can you stop hot going to cold? Show me how you stop hot going to cold. Show me how that's possible. That's a natural law. Show me how that's possible.
Okay, so hang on, guys. So if the only thing, if the only thing that can leave is energy, how did a rocket or anything else escape?
I just told you.
I'm sorry, I've just literally just come back from the toilet, so you'll just have to bear with me.
Okay, even you may not think that Earth is a closed box. After all, you hear of astronauts going into space and walking on the moon. But in fact, it is closed, because virtually all matter, things that have mass and take up space, Ranty, inside the Earth's atmosphere is kept inside, as long as it follows Earth's physical laws. You know, like gravity.
Okay, what keeps it inside?
Okay, listen, only it matters. Oh, I'm sorry. Physical laws. Only if matter breaks these laws does it leave the Earth. Astronauts leaving the Earth is an intentional act, and a difficult one at that. The space shuttle needs an incredible force of energy to break the laws of gravity and exit Earth's atmosphere without burning up. That's how we leave. We just
so
gravity also.
Earth's atmosphere, and that's what they're saying. That Earth's atmosphere is treated as an open.
Even though because you're calling something a closed system, and then you're saying, but it's okay because gas and rockets and spacemen can leave it. That's a load of nonsense.
Hang on, wait a minute. Hold on. Let's get some order here. So I just want to clarify a few of the things that you've talked about. You've talked about a closed box. So would you identify a closed box as a container?
Well, okay. For as far as a container is concerned, Blue Marble showed gas pressure.
No, he did not show gas pressure.
I just want to know for the purposes of this particular discussion, it mentions specifically a closed box, and I'm just asking: is closed box a container or not a container?
I mean, a container can be many things. It can be a sealed container, an open container, and that matters. That's why Blue Marble Science did the open-ended type.
No, he did not. I'll explain Blue Marble Science thing.
Hang on, wait a minute. So is a closed box a closed container then?
Because right before that, he showed.
Sorry, but I do need an answer. I would like an answer to this, if that's okay.
Saying that, and if that container ain't sealed, then there ain't gonna be no pressure. Exact words from Quantum Eraser and Oakley, and Blue Marble Science showed.
No, he did not. It's important that you leave me answer that this time.
Without a container.
Please leave me answer that this time. For a start, Blue Marble Science.
Sorry, hang on, wait a minute. Can I just get clarity on this one point? Is a closed box a closed container?
Well, no. I mean, not if it's not sealed. I mean, we both got to agree that unless you seal the edges, it's not a sealed container, and it's going to only hold so much pressure in there until it opens the lid. You see what I'm saying? So if we just take the box flaps and we flap them over, it's in no way a sealed container, Randy. It's a container. I mean, a bowl that I hold my cereal in is a container, man. Yeah. You know, words have meanings, but they have more than just one single meaning. I mean,
no, a closed system is closed. It can only exchange energy, not matter. An open system can exchange energy and matter. So if you have a closed system, you can't turn it into an open system whenever you want.
So wait a minute. And then energy,
Blue Marble Science. Blue Marble. 1 second. Blue Marble Science brought along a can of butane. Butane within a container. Then he pumped that butane into a long, thin pipe, right? With the top open. right, in a long thin pipe. Butane is, by definition, heavier than air due to its density, right? So the pressure gradient he was seeing inside in that container, inside in that pipe, was highest at the bottom, and it tailed off as it went up because the pressure, because the butane was being pumped in to the bottom of the pipe. So that butane leave that pipe because it's more dense than air. It's not going to leave that pipe until a certain amount of time, until entropy takes place. It won't be leaving that. Right, and I guarantee you, if we put I guarantee you, if we put a lid on the top of that pipe, it would have showed the exact same pressure gradient inside that pipe. Right, whether that's open or not, it wouldn't matter. I told Blue Marmot Science that he was being dishonest with that. I told him he may as well have just opened a bottle of milk, because it will take time for the milk to leave the bottle too. Right, it's not gas container in any way, shape, or form. And inside in that pipe, there was already the same gas pressure as was on the outside of the pipe.
That's not true.
Yes. Before he pumped in the butane, right, the only change that happened in that pipe was the fact that he pumped the butane in from the bottom. But the butane is heavier than the air. So as he was pumping it in, he was causing the butane to lift and cause a pressure gradient within the pipe, right?
Exactly.
But that butane is going to fall back down because the butane is heavier than the air. So, and it's going to take... Especially in a long thin pipe with a small opening at the top, it's going to take a good while for entropy to take place and for that butane to leave that pipe. So that's a demonstration of relative density equilibrium. That's actually what that was.
No, it wasn't. He kept that like
he used a container, right? The pipe is a container.
Right? 3 hours.
The top of the pipe would have been exactly the same. Would have got the exact same outcome.
He kept that like that for over 3 hours.
It would take a good while for the butane to leave. The butane's not going to leave that pipe. It's not going to leave that pipe for maybe a couple of weeks.
Yeah. Ryan, the fact that it had a pressure gradient proves gravity, bro.
No, it doesn't. It proves that he was pumping the pressure, pumping in the gas from the underneath, from the bottom, and that caused the pressure gradient. Just like I told you earlier, the Earth has gas cycles, and the gas is produced at ground level. That's why you have the highest pressure of gas at ground level, and it dissipates as it comes up, like I told you before. But you don't listen to anything I've told you right now.
I'm just going to end this with 2 words. Look, well, that's a straw man. We brought in a pressurized container. Of course, if you have a pressurized container, you got a pressurized system. You got to have a container for it. No one's arguing that fact. I agree with you. I agree that if a container is closed, it's going to be pressure, and it'll have pressure, and it'll have equal pressure because. Right. Right. I agree that I agree that if you want to nitpick words, it was in a container. But how and if you put a top on that pipe, it would not do what Brian said. It would equalize in pressure from top.
Yes, it would. I guarantee you it would be exactly the same, Don. It had nothing to do with the fact that there was an open top to it. It's got to do with the fact that the butane was being pumped in from underneath. So I guarantee you the highest pressure in that was at the bottom where the butane was being pumped in. And it dissipated as it went up. Just like our Earth has gas being produced at ground level. That's why we have the highest gas pressure at ground level.
Pressure, define pressure. How is pressure measured?
My bad, guys. I wasn't streaming then. Sorry, my bad. What happened then is I hadn't clicked my mic audio, so people didn't hear what I actually said. So when they're saying that the sound's a bit skew. If it was my mistake, I hadn't clicked mic audio. What I basically said to Don was when the butane was transported, it was in a container. When it was then used in the experiment, it was also transported into a separate container, which was denoted as the pipe. To which Don actually conceded, yes, okay, in those explicit definitions, then it was in a container. Moving onwards, I then went to say that entropy over a period of time would have taken effect, and obviously those two entropy would have allowed those two to intermingle. The butane would have eventually left the container, but for the purposes of the experiment, it stayed exactly where it was, contained in a container. So I'm sorry if I messed any of that up because I didn't have my mic audio displaying to you guys. But if you guys now want to carry on, that's where we're up to.
And I'm going to add this to it. If he would have put a pipe lid on that, it would have pressurized inside the fucking pipe, and it would have been an equal pressure. Brian's trying to say there had been a gradient. No, there wasn't.
No, pressure. I can show you pressure gradient within a closed container.
Wrong. You're wrong.
Before we
eventually
Blue Marrow, good time for all. He showed pressure gradient within a closed container.
Brian,
using temperature.
You can't have pressure per square inch. Pressure per square inch
in a container. Do you know
per square inch?
Yes, yes. Pressure. You can have pressure gradient in a container. Don't tell me I'm wrong, Don. When I've told you and show you the video, I've told you exactly who made the bloody video. What Blue Marble showed, right? What Blue Marble Sun showed would have worked exactly the same and got the exact same. It would have got the exact same readings if he had put a top on the pipe. The fact that the pipe had no top on it wouldn't change the outcome of it. He's pumping gas from the bottom, right? So as long as he's pumping gas from the bottom, and that's a heavier gas. That's a heavier gas than the gas that's already in it. The butane is more than heavier than the air. Right? So it's going to create a pressure gradient, whether there's a top on it or not.
The pressure in the pipe would have equalized throughout the whole pipe if there was a lid on.
No, Don. What would it? No, as long as he's pumping in the butane, there won't be an equalization of the pressure. Right? As long as he's pumping, there won't be an equalization of the pressure. Yeah. It will equalize later. It will equalize later on. But at that point, when you're taking the readings, it wasn't going to equalize.
Okay, when he's one at a time, please. One at a time.
It was going to be right. What you have to prove first, right? This is the problem, right? You have to prove.
Don, there was already gas pressure in the pipe
and outside the pipe. There was already gas pressure inside and outside the pipe, Don, before he put the other gas into the pipe. There was already gas pressure inside in the container and outside the container before he put different gas, heavier gas, into the container. Right? It was the butane that he was pumping in that caused the pressure gradient. That's what caused it. I can show you a video from Good Times for All, a fellow on our side, who shows a pressure gradient within, right, using just temperature alone, right, within a sealed container. Remember, I told you earlier. I explained to you earlier how we have a pressure gradient. I told you if the relative density equilibrium of gases is temperature, right, and we have cycles, gas cycles. Right. What was
all right? I'm going to tell you what you see. Was exactly pumping in fucking air. That isn't a pressure gradient. You can't say, oh, while he's pumping in the fucking air, there's a difference in the gradient. Of course there is while he's pumping it in.
Yeah, that's when he took the measurement on. That's when he took the measurement.
You know. That is the straw man.
Well, if he used helium, what would have happened? If you pumped helium in, what would have happened?
In top and bottom. He had
Come on, guys, one at a time, please, one at a time.
He won't give 1 second to talk, so fuck him. I'm going to over talk him. You know what I mean? If I can't get one word in, I'll just over talk him. You know what I'm saying? Because that's bullshit. I sat there and let him talk for 5 minutes and didn't say a word. Now, the guy having the fucking propane tank in a fucking bucket of ice and using a propane torch on the top of it wasn't a pressure gradient, Brian. That was a higher pressure on the bottom. No, it was a higher pressure. It wasn't a pressure difference. There was just a pressure difference in the top and it was a
changes pressure. Don.
That was not a gradient.
Changes gas pressure, Don.
It wasn't a difference. There was just a different pressure. A gradient. A gradient goes from 14.7 to 14.6, 14.4, 13 to 12. That's a gradient.
Okay, so listen, I can't hear what you're saying there, Brian. Is there something that you're trying to say in this particular part? Because whatever you're saying, it's being drowned out. So could you just repeat just now what it is?
Yeah, I will. Temperature changes pressure. He's trying to say now temperature doesn't change pressure, or that Good Times for All didn't prove gas pressure gradient within a container.
Okay, what would you say? What would you say, Dom? That temperature changes pressure.
I said that it changed it It did change it from lower, a little bit higher to a little bit lower. There wasn't a gradient. A gradient is a change throughout the whole length of that propane tank, and there wasn't a gradient in it. Just because the bottom had 6 psi and the top had 5.6 wasn't a gradient, Brian. Learn what the fuck a gradient is.
A gradient is
That's not a gradient.
It's
different than
the gradient is non-uniform.
That's not a gradient. You're wrong.
It's non-uniform.
But it
doesn't matter. He proved gradient, a pressure gradient within a container anyway. He proved it.
You say that
in a container. So I don't know what the argument is.
Say, Brian, look up gradient.
I know what gradient is.
14.7.
Share a video from Blue Marble Science with you. 2 of them that he shows a pressure gradient within a container.
Oh my God!
Okay,
dude.
so just for the purposes, just for the purposes of this discussion right now, would you concede or would you agree that the butane was contained during this experiment?
This is what I'm going to do. I'm going to say that he gave Quantum Eraser and Nathan Oakley exactly what the hell they asked for. They said, and he put it in his video, word for word, Randy. Quantum and Oakley both said, "Oh yeah, and if that container ain't sealed, buddy, he won't have no pressure at all. And if it isn't sealed, then he won't hold that pressure for more than 30 minutes." Okay. And he proved them wrong.
So excluding Nathan Oakley and Quantum Eraser for the purposes of this for the purposes of this topic, what we're discussing right now, would you agree that the butane was in fact contained?
Well, I will agree that if he would have had it in a salad bowl, you guys would have said it was contained. That's what I will agree to, because he gave them exactly, Randy. He gave them exactly what they asked for, brother.
No, he did not.
They asked
in any way, shape, or form. No, Don, he did not.
I'll tell you right now.
No, he did not. For a start, where was the vacuum? For a start, where was the vacuum in that test?
Video.
Where was the vacuum? Where was the vacuum? Remember
the video
earlier that there was 14.7 or whatever the general gas air pressure was exactly the same inside as outside of that pipe, right? Remember I said that there earlier, right? So where was the vacuum? Because what we asked for is gas pressure, right, next to a vacuum without a container, right? That was never ever and will never ever be provided, right? For the gas to sit next to a vacuum and not dissipate and not equalize into the available volume. That is not what Blue Marble Science showed. What he showed was a pipe with the same air pressure, gas pressure, inside as outside, and then he pumped in a heavier gas into the bottom, creating a gradient within this long thin pipe. Right? It wouldn't have mattered whether they put the top on it or not put the top on it. The gradient would have still happened. There was no vacuum involved in that whatsoever, and there never would be. And if he used, and now answer this question now, point to you for you to answer a question. If he used helium, what would have happened?
They said, you can't show me a pressure inside of a container without it being sealed. That's what they said.
That at all. That is not what they said. That's a misrepresentation of them completely.
Okay, hang on, one second. I'm not going to listen. Just a minute. Just a minute. I actually think, and I'm going to back Don up on here, that was actually said on a particular stream. Now, I don't know whether they still believe in that particular thing, but it was, from what I recall, and I'm just being honest, that I do actually feel that is what was said. However,
I remember what was said, Randy. I remember what was said. What Quantum Eraser said.
I can't be 100%, but I'm about 90% that's what I think they said.
No, that's not what was said.
Okay, if I'm wrong, and they're my buddies, so I'm kind of throwing them under the bus here, but it's how I remember it. But that if you remember it differently, that's different.
So why wouldn't they use that, Brian? Your argument makes no sense.
No. But listen. Regardless of what, I just want to clarify. Regardless of what they said, or what they may have said, or how they may have misspoken at the time, the simple fact is hang on, wait a minute. The simple fact is that the butane was still contained, and even if you say you put it in a salad bowl, it would still have been in a container. A salad bowl is a container. A cup is a container. you know, it would still have been contained.
But all that doesn't matter. They're talking about. Oh my God!
I want to about this because I don't want people being misrepresented. Right? What Mirages said, what he said, let me say what's wrong. What's the problem? I just don't want people misrepresented here. Right? Well, let me say.
Hang on, one sec. One at a time, please. One at a time.
It's not fair for someone to be misrepresented. I don't care from the globe side or the flat earth side. I want them to not be misrepresented. Right? What Quantum Mirages said was that butane would dissipate within 3 hours, right? Due to entropy. Now, what happened is it didn't dissipate that fast. It was still in the pipe 3 hours later. Right. He was wrong. It took longer. I don't know how long it would take. I reckon that's what Quantum Mirages. He was wrong about that. It took longer than 3 hours. It didn't matter. His point was eventually it would dissipate due to entropy.
You're just lying, dude.
The argument was in there originally.
It was over. We lived in a dome, in a sealed dome, Earth. So your argument doesn't make sense, man. You're trying to argue saying that
makes perfect sense. I've been saying about a dome.
His exact words, were, and it ain't sealed. There's gonna be. He ain't never gonna get it to work. Those were his exact words, Brian.
No, that's not what he said. He didn't even know about. How could he say he'd never going to get it to work? He didn't know it was going to happen until he saw the video. How could he say?
Hang on. One thing I want to clarify as well is that for at least 1,000 times in the past year, either Nathan or Quantum Mirages combined have said, quote, "Show me gas pressure without a container." That's what they've said, and they've not qualified whether it's sealed or unsealed. But you know, so and from what I recall, if there was the one time that they said sealed, you know, that doesn't negate the fact that 1,000 times they said, "Show me a container." Show me gas pressure without a container, and that is their rhetoric. That is what they mean when what they say. If they misspoke one time.
Randy, you can't say that. You can't say, "Show me something without a container," when your argument is, the whole argument is, we live in a sealed container. So by comparison, what are you saying? He showed you a fucking
gas pressure without a container next to a vacuum.
Gas pressure container with a gradient is what he showed him in a container that wasn't sealed.
He didn't show a gas pressure gradient without a container next to a vacuum. He didn't show that.
It showed gas pressure in a gas pressure.
It showed a gas pressure within a container that already had gas pressure in it, and he put gas from one pressurized canister into a different pressurized canister. One pressurized container into a different pressurized container, and he put a heavier gas into the second container, which caused the gradient. If he had the top plugged up, it would have still shown a gradient. It wouldn't matter. And there's no vacuum. Where was the vacuum in the test? Where was the vacuum to prove anything in this test? He did it in gas pressure. He's within gas pressure.
The whole argument, container, brother. They said, even Quantum Mirages' own words was, and if he doesn't have if that container ain't sealed, it's Dick's form that'll never hold. It'll never hold the gas, and he'll be lucky if the gas is held for 3 minutes. Then it went to 15. Then him and Oakley was like, 30 minutes. I know what I'm talking about. I've watched the video several times.
Well, I heard Quantum Mirages say, the exact words I heard him say. Now, maybe it's not the same exact. Maybe it wasn't the same exact stream or something, but the exact words I heard him say was that it would dissipate within 3 hours. And Blue Marble Science went and showed that it didn't dissipate within 3 hours. So Quantum Mirages must have said it if Blue Marble Science was so specific about showing it 3 hours later.
He did.
Well, Quantum Mirages must have said it would dissipate within 3 hours. He must have said that because Blue Marble Science made a point of showing that it that he was wrong, that it didn't dissipate within 3 hours.
Exactly.
He pumped gas pressure into gas pressure. That's basically what he did. There was already gas pressure in the pipe and outside the pipe. We're living in gas pressure. The problem is we can't prove how we can have gas pressure without a container. You're not proving a container. And you still argument how we can have gas pressure in any form, whether pressure equalized or gradient, next to a vacuum. There is no proof whatsoever there of that. I showed
their whole argument.
the
You
bromine.
couldn't have gas pressure in a gradient without a container.
On screen right
You
now,
couldn't
because
have-
we're never going to get anywhere with this argument. We've been going over it for about 40 minutes, and it seems like we're just never going to get to it. It's just going to be just an argument. I want to try and change things around a little bit, and
He's just wants to say, regardless of the facts of the matter are, they said that there was no way he would have a gas pressure unless it had a container, unless it was sealed. That was their exact words. That was Quantum Racer and Oakley's exact words. Then they went on talking shit about, and if it was open, how it would never hold pressure, and the pressure.
Words together, because you can't like to misrepresent people. I wouldn't misrepresent someone on the globe side. I don't do that. So you're telling
nobody.
Ryan. Oakley said that the same exact words together.
Okay,
I'm not.
I'd like to change subjects until we can clarify one way or the other, because, you know, bringing in Nathan and Quantum Eraser without the citation, just sort of like hearsay from my side, hearsay from Don's, hearsay from Brian's even. You know, if there was this one particular time and the sound bites out there, I'm sure it will be available for people to hear. But right now we don't have that, and it just conjecture. So we're not really moving this forward right now. But one thing I would like to try and move forward, if possible, is that I've got on screen right now on the watch page, we've got the Lunar lander. So inside the Lunar lander we have a pressurized container, and we have the vacuum of space on the outside of it. And on Earth, right, inside, to try and recreate or get anywhere close to, which they don't get close to anything close to the vacuum of space, bearing in mind, but they are able to create a vacuum inside this chamber. It's called the Space Simulation Vacuum Chamber, and they have to have 30 foot concrete walls to separate the pressurized system of our atmosphere from the vacuum inside the chamber. So what they
say though about that, Randy, just to clarify, is that they say that that it was built that strong to also test nuclear weapons and stuff in it. That's part of what they say, why it's built so strong. Now, that's what they say.
I haven't listened to anything that you said. I'm sorry. I was trying to find this video from Blue Marble. What are we talking about? You're talking about the vacuum test chamber in NASA?
The vacuum test chamber, which requires, I think, 30-foot deep walls to provide this vacuum on the inside with the pressurized system on the outside. Yes. And yet sorry, go on.
It's not only used for testing vacuum. It's not the only thing it's used for. You can go right to their website and see all the different things they use that chamber for.
Okay, so would you be able to recreate, looking at the Lunar lander, would you be able to, using the materials on the Lunar lander that's on screen right now, recreate a vacuum chamber here on Earth to give a pressurized atmosphere on the outside and a negative, a vacuum on the inside, equivalent to the space that it traveled through? Would you be able to do it using the materials that they have on screen right now?
I just want to clarify something. They never actually did anything other than vacuum in there. They've stated that, but they said they built it for doing other things to do with nuclear stuff, but they've never actually tested any nuclear stuff written in there. So they've only ever done vacuum stuff in that.
Okay, so the question still remains: the materials that they had on the Lunar lander. Would you be able to take those same materials, take them to Earth, and out of these materials, make some kind of chamber that's able to withstand the pressure differentials between what you see apparently on screen right now, which is a pressure inside the container, and the vacuum of space on the outside? Would you be able to recreate that on the Earth with these materials?
Me personally?
Well, even NASA. I mean, would you think that the materials that are on screen right now, do you think that they would be sufficient to create that kind of chamber, or do you know?
Yeah, I honestly couldn't say yes or no to that, because I'm not a structural engineer, and I'm not a lunar module designer, or you know what I mean. So I can't give you an answer to that. My answer to that is that obviously I don't understand what you mean by that, since all they would need is basically their own atmosphere inside there. I mean, so I don't understand what you know what I mean. I don't I don't really follow. You know what I mean?
Well, what Randy's saying is that can you create a situation where they can have a gas pressure within that module with those materials and have a vacuum of 10 to the minus 17 outside of it and be able to go in and out of that module, and that module not that the gas pressure within that module hold up and the gas not equalize into the vacuum.
Who says it? Who said it didn't do that?
Well, if
if it did do that, they would be dead.
Yeah.
What, it would do that when they had their spacesuits on? They'd be dead.
Well, the lunar lander would have never made it back to the capsule that supposedly took them back to the Earth.
Yeah, there's a lot of other things in there to be affected by the vacuum.
Wait a minute. But what would stop it from when they closed the door and locked it, sealed it, for it to
once they open
repressurize?
Don, once they open it at all, any gas pressure that's in that is going to equalize into the vacuum.
I understand that. I'm not saying it wouldn't. You're absolutely right. It would do that. But once they went back in it and they shut the door, what would keep it from repressurizing? What would make them not be able to like push air into there and repressurize the inside of that lot?
Well, would vacuum have an effect? Like, I don't like. It's not my argument. This Randy just put this up. Look,
I'm not an expert at that. All I would say and to be honest,
you could have oxygen in there.
I'm using sci-fi.
The reason I asked this,
but my guess is that question you for that stop them from shutting the door, because obviously when they're in that lunar module, they got their spacesuits on.
I have a question for you about this.
Well, before you ask that, I just want to clarify, because you brought me into this. You sort of like referred to me just back then, Brian. But the reason I brought this particular argument up was because that I did actually watch your video there, Don, a couple of days ago that you released, and you talked about what's it called? The rover thing that runs around the lunar surface. So you talked about how the tire tracks, etc., weren't in the image. So I assumed, I thought for some reason that you was like a lunar lander expert in this. So that's why I brought this up.
No, I was just aware of that picture. Picture was actually a picture taken of when they set that lander down off of the module. I'm aware of that picture. I've seen that picture, and it's a cherry picked picture of the wheel after it was set down off from the lunar lander. That's when that picture was taken. It hadn't been moved yet. It had just got set down off the crane on the lunar module. Just got set down. That was a dishonest cherry picked picture, and the person who made that video was dishonest, 100% dishonest with that picture. Unless they just didn't know. But I have a hard time believing that they didn't know with some of the other things that they said in their video.
Okay, I have a couple of questions about it, right? This whole thing here, right, that's supposed to be on the moon is made of matter, right? His suit is made of matter, and the person in the suit is made of matter. If there's someone else in the lunar lander, they are made of matter, right? Now, we're supposed to be in a closed system, but yet matter can leave it somehow. And how can they leave this closed system with this matter and all the atmosphere not equalize into the available vacuum? As that's what happens. That's what entropy does. That's what happens. Gas always equalizes into the available volume, especially when it's of a lower pressure, because high pressure always goes to low pressure.
As much as you don't want to hear the answer to that, it's gravity. As much as you don't want to hear that answer, I'm sorry.
In a billion years. 10 times over. Gravity 10 times over wouldn't overcome. If it was real, 10 times over wouldn't overcome entropy. At ground level, gravity is at its strongest, right? At ground level. Yes, I can show you the video showed you earlier with the bromine going directly into the vacuum. Gravity didn't stop that.
I mean, there's but here's the difference: is that you're trying to explain why with all the particles up near the Kármán line up there in the higher atmosphere, Brian, there's not much up there. Our atmosphere goes almost to the same as space. There's not much difference. There's not much pressure at the Kármán line. There's not much pressure. There's not much pressure up there, Brian. So, or there's not much air.
There is no Kármán line. Does high pressure go to low?
I just told you.
Don. Does high pressure?
And I've admitted we lose atmosphere. We lose several hundred tons of atmosphere a day.
No. Okay, listen.
That's facts.
Don, high pressure always equalizes into low pressure. That's what always happens. Right? It happens all the time. There is no example of it ever not happening. Okay? There's no example of it ever not happening. Actually, Blue Marble Science's videos are great examples of that situation. Is that the pressure that he's pumping into the thing, even though the gas is also heavier, but the pressure doesn't need to equalize because the pressure on the inside and the outside is the same.
Nothing you say is making sense, though, Brian. You're trying to argue a point that you don't even get.
Not making sense. I'm not the one who's not making sense here, Don. You're trying to claim a closed system that matter can be, and that we can have a vacuum next to a gas pressure, and the gas pressure not equalizing to the vacuum. There is
to get an answer out.
Show me physical demonstration, right, of gas pressure next to a vacuum. Gas pressure not equalizing into it. That's what you have to.
I know what I have to do is just make you eat your own fucking words, and you've already admitted to a fucking gas pressure gradient. So case over.
Gas pressure gradient starts with gas pressure. You can't have gas pressure without gas pressure gradient.
That's an argument.
Sorry, you can't have gas pressure gradient without gas pressure. You need to have pressure. You can't have gas pressure. You can't have gas pressure. You can't have gas pressure without a container.
According to your own words.
Gas pressure without a container.
Gradient. So there wouldn't be no gradient.
Container. You have to have a container to have gas pressure. You have to have gas pressure to have gas pressure gradient. So go from container to pressure to pressure gradient.
Yeah, okay, listen.
Explain the gradient, Brian. You don't make no sense in what they don't make sense.
You earlier. You tell me what I told you earlier then, to see if you were listening. Tell me what I told you earlier. I explained it to you.
Well, there's 14.7 psi on Earth's surface.
I explained it to you earlier. Please tell me what I told you. We'll see if you were listening.
I just answer it. Just answer the question.
Please give me the explanation I gave you earlier. We'll see if you were listening.
You don't want to answer the question. I get it.
No, I want you to answer the question. I want you to tell me what I told you earlier. I already explained the pressure gradient to you, right? Now, I need you to tell me back verbatim what I told you.
Word salad. That meant nothing.
You were not listening.
No.
This is the second time in this debate you asked me for an explanation of gas pressure.
Okay, listen.
I told you it already.
I'm going to do 15 more minutes. I'm going to do 15 more minutes, guys. I'm going to do 15 more minutes. So,
he never gets an answer for nothing.
Sorry.
He just answered the question with a question, Randy. There's no arguing with him because
I was asking a question, Don. You're projecting. You answered the question.
You said high pressure always moves low pressure. And I said
to explain the pressure gradient. Then I told you I explained it to you earlier, and I asked you to tell me what I told you.
Explain it.
Do you remember what I told you, Don?
You didn't explain it.
I did explain it. I explained it very well. Do you remember what I told you?
Thing moving to low pressure.
I told you.
Why pressure in Earth's atmosphere moving to low.
Can you tell me what I told you? I want to know whether you're listening or not, because I want to know whether you're just wasting. Because I'm not going to tell you it again if it turns out that you were just wasting my time the first time.
Since with
this
questions,
is not the first time in this debate that you've proven to me that you haven't been listening to anything I'm saying.
There's no point because you answer questions with questions.
With a nonsense talk, but you're not coming up with any proof of anything, and you're asking me to explain stuff. I'm going to give you explanations. You don't even know what I told you because you weren't listening. So don't.
You didn't even know
stuff if you're not going to listen. Don't waste my time.
Christ, mind, you didn't even know Earth was a closed system, dude. You don't even know science.
First of all, I know it's a closed system. I was the one who was able to define isolated, closed, and open. Is that you're trying to say a closed system can exchange matter? It can't. That's an open system. It's not to be a closed
He's not. You're an idiot.
Okay,
so you're saying.
So hang on, wait a minute. The ad homs. It's not really. It's not great listening to the ad homs. It's not great listening to the idiot calling stuff. But
when he says that, when he's talking, only things matter. What is energy? Energy's matter.
Energy's not matter. Energy is not
matter.
Energy is not matter.
Okay,
God,
so
dude.
Hang on, wait a minute. So just a minute, guy. Listen, please. I really need to get this in here, right? You guys have been at this for the last 2.5 hours, but something personal to me, something that I would like to know, because we've actually got Don. We've actually got Don on, and Don is. No, listen.
One of my. Period.
I just want to say. Listen. I just want to say.
He's saying pressure moves to low pressure, but he can't explain why it doesn't do that in our own atmosphere.
Right. Okay. So
there's a vacuum at the top of it, Don. That's why, and it does go to pressure. Pressure does. That's part of creating the gradient. Now, please listen to Randy, moderator. He's trying to get it.
Okay.
Pressure always moves to low.
Okay. So, for me personally, I mean, I've moderated you guys for the past 2.5-3 hours. I would like something from Don, if that's okay. And that's just a couple of questions about the lunar lander, which is on screen right now. So if you've got the time, Don, do you think you could just answer a couple of questions for me?
If I know it.
Okay.
I'll try.
And the reason I'm asking you is because, like I say, I saw your video about flat Earth a couple of days ago. And like I say, I thought you were an expert in this particular discussion. So this is why I brought this to your attention. And there's a couple of discrepancies that I see on there's 3 actually. The first one is all the warping that's going on these panels and these apparent gaps that are around the the joins, the seals of this lifeboat, so to speak. It's a lifeboat for these astronauts. So is there anything that you would like to ask to talk to me about these, or to explain why you think these are all so warped?
I mean, I don't know why they're warped. I mean, what's behind that? Do you know? I mean, you ask questions that.
I don't know, you know the answer, I genuinely don't know. It's like this is why I'm asking you, because I thought you might have an answer for this.
The module was made in layers. It wasn't just a single wall between them and outer space. I mean, there was several layers of containment. Just like their suits. Their space suits ain't just a couple of small thin pieces of aluminum foil. They're layered. I'm not exactly sure how many different layers there is, but there was a lot of layers that's involved in their suits. And the same with the lunar module. It's not just them little pieces of tin that you see there holding the life-breathing, life-giving oxygen inside, Randy. You know what I'm saying? I'm sure. I mean, I watched something a long time ago, when I watched a video about how they made the lunar lander, and it's basically what they was in was basically pretty much a solid ball inside that. You understand what I mean? Like a solid ball of metal, like with a hatch. You understand what I'm saying? So imagine take a submarine and shrink it down into a ball and put a hatch on it. That's basically what's inside that module. And it's been so long since.
So my next
yeah,
question,
that's probably something like maybe covering like maybe some electrical systems, or who knows, covering some other stuff that's over top of electrical systems. Because I know they wrapped all the wires and stuff like that in foil and things like that. Because actually, with the Van Allen radiation belts, the aluminum
didn't know existed at that time.
No, they knew it was there. They knew that was there. They flew.
Astronauts said they didn't know about it.
They plotted the course. Well, maybe the astronaut. NASA knew about it. They actually flew over the.
What a minute! So they didn't tell the astronauts they were going to fly through a dangerous radiation belt on the way to the moon.
I couldn't tell you if they knew about it or not.
Okay,
I mean, you're saying they.
I'm just saying they said that they didn't know about this.
No, I mean, from what I've read, that NASA knew about the radiation belts, and they knew that the course they plotted took them at a higher arc, like an arc over top of that, to where they only went through a smaller portion, a portion that wasn't as high in radiation. The Van Allen belts goes through phases where it has some parts of it is higher radiation than other parts at any certain time.
Okay,
so that's right.
So that's your answer for that one. My next point is, on the right hand side of this lander we have this trim that runs down, and we come up to this join on the right hand side, and what we see on this join on the right hand side is we just see a join. We don't see anything out of the ordinary with that. However, on the left hand side, when we come down across this apex, I'm going to call it an apex, because obviously I'm a painter and decorator, so we've got this apex coming down, and we've got the trim, and it stops in roughly the same place. But this join, this join that's here, what we have is, clearly we have some duct tape, and the duct tape is underneath the trim. So if you actually zoom in, you'll see that the trim is on top of the duct tape. Now, I can't imagine NASA sending these, this is a lifeboat essentially for the astronauts, I can't imagine them putting some duct tape on the lunar lander and then putting the trim on top and then sending that off to go and fly into space. That would appear to me to be some kind of retroactive kind of repair that went on. Would you agree? Because I'm looking at this and that's quite high up if you look at it where it is on the lunar lander. Would you agree that that's sort of like a duct tape repair on this piece on the left hand side?
I mean, I couldn't tell you if it's duct tape or not. I mean, honestly, I ain't gonna dog duct tape either, because that's some bad shit. No, but you know, I mean, I wouldn't I wouldn't go out.
If you don't know, you don't know. That's fine. My last question is very simple. They've sent this off to space. It's going to be landing on the moon. It's definitely a, you know, like a Ferrari or a McLaren. You know, when you were doing the F1, you know, you want your car to look the best. You want it to be shiny. You want it to look great because it's going to be all over the news. You want these images to look brilliant. But what we see is these panels are different colours. We've got like some light duck color blue, and then we have some kind of like sandy beigey sort of color on the other panels, and the different colors. I mean, does that strike you as like trying to say, hey, this is the height of the US achievement here, this is the pinnacle of what we're doing, we're going to send these men to the moon, and the panels are even the same color? Does that sort of like ring any bells with you as to this is how they would have done it back then?
I mean, I don't think that they really gave us. I mean, personally, I think it was more of functionality and making sure the astronauts were safe than it looking like a Ferrari to me. I mean, to me, my main priority, if I was an engineer for this, would be to make sure that what gave them life didn't fail, was safe, and they came back alive. I wouldn't care if the panels were a couple different shades of gray. You know, I mean, I don't know if that happened in transport. I don't know if that's maybe some kind of discoloration in the way that it's sitting in reference to light. You know what I'm saying? I don't know.
Okay, I mean, that's fine. I mean, I'm just asking some questions, you know. I mean, honestly, that's it.
An honest person. I am honest, and I will say that panel looks like shit. You know, shit. But, I mean, I will be honest with that, but you know, I don't know what the panel's for, so I can't say that that's keeping their life saving. I hope to God, if it is, then it's a miracle on earth that they got back with that. But you know what I'm saying. But I don't think that has really much anything to do with the functionality. So you know, that's my point.
I have no idea what these in the bottom corner you've got what appears to be, now I'm not going to say it is for sure because I don't know, it could just be some kind of malfunction on the camera, but it appears to be some kind of rust that's going on around these nails. I'm not going to include this in the cross-examination of what this is, but it's just interesting to point this out because, you know, this thing was just a few days ago on the Earth, and should have been under lock and key in a hangar somewhere, being meticulously gone over with a fine-tooth comb. And if it was me and I was the US and had invested so much money in this, I would have made damn sure that this thing looked the best it was going to look. And any kind of rust, any kind of different colour panelling, I'd have given it a spray job before it went off. I'd maybe even put some flags on it, the US flags, hey, we're here, but these panels just look incredibly poor. I've got to say, if this went to the moon.
They do, and I'm going to tell you something, Randy. I mean, as good a point as that you're bringing up with that, okay, I'll counter it with this, that we didn't know much about space. We damn sure didn't know nothing about what was going to happen to anything about them, when they landed on the moon. This was all shit that they basically were guessing at because we were in a race with Russia to get there. You know what I'm saying? So was shit probably rushed and rushed to get done? Oh, I'm sure it was, and that's probably has a lot to do with the way that shitty ass panel looks,
Yeah, but have you got to say that rushed? I mean, come on, this is going to the moon. This is going to be shown worldwide. I'm going to use your terms. It's going to be shown globally, right? It's going to be shown globally, and this is how they present it. I mean, come on, seriously. From our point of view, we look at this and we think this isn't what you would imagine space age technology to look like. They lost this technology, thank God, because they can't go back to the moon. So they lost this technology, right? And they can no longer go back to the moon.
We can go back. See what people, I see saying that all the time, Randy. But the difference is the Van Allen radiation belt affects electronics more than it does people. And the type of electronics we have now, that the computer's probably going to do 99% of the work. One thing with us, with our technology, it's made us lazier. And, our astronauts are probably going to depend more on the computer systems in anything that goes there in 2024 than these guys did. For an example, them saying that John Glenn took the reins of the lander and landed it manually because it was going, veering towards a rocky area. These new astronauts are probably so idiotic they probably wouldn't even know how to do that. I mean they probably will. I mean, I'm not saying, but back then we did our own work. You know what I'm saying? Where nowadays we're more dependent as a society. If the sun was to pop out a solar flare right now and knock out computers and technology, we would be in the fucking Stone Age. You know what I'm saying? So my point to that is that man's dependency on computers and technology is way too dependent than it was back in '69. You know what I mean? And the perfect example of that is John Glenn landing that on the moon. He's seen it going somewhere it shouldn't have, and he took it over. He probably just flipped one switch. Where if that happened in 2024, they'd probably have to hit 35 switches to get manual control. You see what I mean? It's going to be. That's the problem, is that getting through the Van Allen radiation belts now with our technology, that's the problem. We can get to the moon. They didn't lose that information. They lost a lot of the notes that each person, that scientist and engineer working on the Saturn rocket and the moon lander and the rover, they lost all their, like notes and personal notes that, you got to think these scientists over there, they're working on something. They say, oh, wait a minute, that don't work. Oh, but this does. So they probably just wrote that in a notebook. Like, oh, I had to do this, That's the kind of shit that they lost. We can make it to the moon, man. We can send probes to Mars. We can land telemetry wise on the moon. That's not, there's no question about that.
Okay. But, so looking at
that's fine.
Looking at the feet as well. I mean, they barely look like they're touching the surface. There's no dust on these feet, and also the jet that comes out of the bottom, the thrust that would be producing, you would imagine would create at least a modicum of a crater, perhaps on a very dusty surface. But it doesn't appear to be in the image. I mean, what would you say to my subscribers that look at this and say, okay, it doesn't look like that thing has had any kind of dust contamination or any kind of thruster activity underneath the lander. What would you say to that?
Well, from what I understood, they landed in an area that was more rocky surface than dusty. From what I heard, from what I've read, and I mean, in that, that's the explanation that I've understood. My question is this to all these people that believe in flat Earth: why? What does anybody have invested in lying about the shape of the Earth? Why does it matter when you get up tomorrow if the Earth is flat or round? What's it matter?
Well, it would change
Who
a lot.
cares?
It would change a lot. It would change a lot for the Earth to be different than we're told it is. Well, if the Earth is flat, right, and contained as I absolutely believe it is, then I also believe it's a construct. That would make it a construct, which means there is a creator, which means we're not here for no reason. So just some random organism on a speck of what would be dust in a massive vacuum of a universe.
So you want to be special?
It means that we're not. It means that we're not. It means that we're not insignificant, and we will have to answer for anything we do.
So meaning that we're special, then you want to be special?
I don't want to be anything. It means that we are created, that this place is a construct, that this place is created for us to be here.
You care if there's a God. Why would the government care?
Why would the government? I don't know. I'm not going to divine the government's thoughts. No, I don't know. I'm not going to say they lie because of this, they lie because of that. But the difference between a globe Earth and a flat Earth is a globe Earth. A globe Earth. If you believe in the globe Earth, then you can either decide to it was created by a creator like God or whatever, or you can decide that it was the Big Bang and whatever else. Right? It's still creation. They're both creation. Just one involves a creator. The other one involves some kind of a cosmic accident or something. I don't know. But the thing about it is that the flat Earth, you can only have one. There is only one choice with the flat Earth. It means it's constructed, that we are not an accident. It means that we are the center of things, and we're not just a random insignificant organisms on a rock out in space. Do you understand? We're not an accident.
You're ignoring. But you're ignoring so many things. And I don't want to get into, because I'm pretty much done, man. We've been on for a couple 3 hours. But ignoring things, like the difference in the northern and southern star patterns. They rotate the opposite directions, man.
They don't.
There's things.
They both all go east to west. That's not true. They all go east to west. And you can go to a high location in Ecuador, right, on the equator, and you can see both Sigma Octantis and Polaris above the horizon.
You're going to deny the star pattern rotation. You're denying that when that's a physical thing you can go see.
No, they go east to west, right?
Are you? But you're denying that
all the stars go east to west. They don't rotate opposite in the southern hemisphere. That's not true. They all go east to west.
It's all true, man. Yeah, I'm sorry, but you denying it doesn't make it wrong.
What happens is it's two spirals, right? And the stars come from each.
I am going to take this time to take a massive thank you to Aaron Moorfield for super smashing the super chat right now. Cheers to the physics degree debater. Holla Aranti. Thank you very much, Aaron. Really appreciate the support there. Thank you.
Magnetic north, straight up, right? Let's just say there's Polaris. The best we can tell, there's Polaris, straight up, right? Sigma Octantis is that's one's vortex, right? The other vortex is on the outside of that. So one is in the center and one is on the outside, and they move around. The one on the outside moves around.
You can't see the North Pole from the southern hemisphere, and you can't see Sigma Octantis from the northern.
No,
you just things you can't get away.
It's too far away. It's perspective. You can't see. You can't see that fast.
But you can't keep using bullshit explanations. Perspective doesn't.
If you move, if you start moving south, Polaris will start dropping in the sky, right? in the northern hemisphere. If you start moving north, Polaris will start rising.
Perspective isn't a free word that you can use to explain anything and everything that you don't understand.
No, but it explains the things that it does actually explain.
No, it doesn't.
You can't
because you guys try.
You can't
you guys
see Sigma Octantis from Ireland because it's too far away.
Won't use it as for the sun. You see?
Well, I'll give you an example. Right? If you stood inside a factory that was 4 miles square, right? So it's 4 miles in every direction square, right? And you're in the center of that factory, right? Can you see something on the ceiling of that factory, right? That's 2.5 miles away from you. Can you? Just be honest. Would you see that?
I mean,
that's only 2.5.
Telescope, I could.
And if you went out to 2.5 miles away from the center, would you be able to see stuff on the ceiling of the center? 2.5 miles away.
A telescope, I could.
I'm asking you. I'm asking you. No, not critique. I'm asking you. Could you see it with your eyes? Could you see something on the ceiling? Let's make it 8 miles square then, or 10 miles square. I don't care. Let's make it 10 miles square then. 10 miles square.
Right, but it doesn't. This fact. The fact is that we have shit that enhances our sight. And things like on a flat Earth don't make sense when you talk about it. Just like you're saying that. Listen, flat Earth, the sun gets further away. Then you tell me, why can't I take a drone? Let the sunset, take a drone, go up 100 feet and watch the sunset.
P1000 camera with IR filter, right? Which means it sees through a load of the atmosphere. Can still only see so far. You're not
bullshit.
The height
of a drone doesn't change atmosphere looking through an atmosphere. When the sun sets, if I see the sunset and I take a drone, I go up 100 feet, I can watch that sunset again. When it does it again, I can go up another 100 feet.
Can you show me a video of a sunset from an airplane?
What?
Can you show me a video of a sunset from an airplane? I've yet to see that.
I don't know. I probably could if I looked for it.
But be looking for that. And I was like, no, I could be wrong. Could be wrong.
And video of sunset. They did a sunset experiment where they took a drone and they watched
what I said earlier about the diffraction limit, because our angle of view is complete.
I'm treating myself.
It doesn't mean nothing. Oh, dude. If that's the case, then when the sun sets, as soon as the sun sets over the ocean, I could be on the beach, and immediately I see it set, I can look through my telescope where the sun was, and I should be able to see that sun again.
You'll only be able to see as far as the telescope can see.
You can't get away.
Telescope can see. So that's as far as Randy's drinking. You'll only be able to see as far as the telescope can see. You won't be able to see indefinitely. That won't happen.
My eyeballs. Once I see them with my little bitty eyeballs that are fallible and bullshit. Once I see that sunset, I look through a telescope at the spot where the sun was. I should be able to see that sun again. Because if it moves further away, the minute
you should be able to see the sun if you can follow it. Yeah. The sun is moving pretty fast, and it's high in the sky. And once it goes past the horizon point, then even with a telescope, you're going to have a hard time tracking.
It's the speed, Brian. If it takes
that, though,
for the last
it's
to disappear.
That's the same thing as saying, if I lie on my back on the beach and watch or my belly on the beach and watch the sunset, if I jump up, stand up straight, I still be able, when the sun goes down from my belly, when I jump up straight, I can see the sun. Yeah, because your angle of vision is better. Now, a telescope will help you see further. Help your angle of vision.
Parallel lines don't intersect by definition. So, by your model, there should never be sunlight on the bottom. No, there should never be sunlight.
I missed that part.
Clouds.
What did you say? I said intersect on.
I said parallel lines never intersect by definition. So never should there be sunlight casted on the underneath the sun clouds. And just because I'm looking out at the distance doesn't mean that I should be able to see more because I stand up. Unless I'm looking.
How do you know there shouldn't be sunlight on the bottom of clouds?
And if Earth is curved, it would not bring the sun back up. Unless I'm looking over.
So your only fight against the flat Earth is the fact that, from what I can get, the only fight against the flat Earth, the main fight you have against the flat Earth is that you can't understand how the sun works on it.
Oh, no. I understand how the sun works.
I mean, I explained stuff to you earlier, and I guarantee you're going to hear more about that stuff, even probably from other people. because there's a lot of people will be looking into that. What I said earlier about what the sun does, right? And
Listen,
fraction in it, right?
You could.
That's
I'm going to hear
that's
shit.
something that is a real thing that I can prove is happening. I can prove it's happening. I'm
assuming
of it.
And 8-inch per mile squared. But sorry, Globe Earth did not say that. That was a flat. The guy who created
that's sure your core calculators say it's 7.98 inches per mile squared. That's your calculator. Why would the globe? Why would Metabunk and Walter Bisling? Why would Metabunk and Walter Bisling and Bishart or whatever it is, and all these other ones? Why would they use that calculation if it wasn't a calculation? If you don't use that calculation, right? I know that it's a parabola, but if you don't use that calculation, then how are you going to have a globe of 24,940 miles?
If I use that, how am I going to get
that calculation? Comes from the equator size.
If I use that, am I going to get a globe, a sphere? That I can't. So you're saying that I can use that 8-inch per square mile and get the circumference of Earth, and I can't.
No, I didn't say that. I said I know. I didn't say that. I said I know it's a parabola, but it comes from the fact that you have an equator size of 24,940 miles. It comes from that. That's what I said. I didn't say that you would get a sphere out of that. I said it's parabola.
No,
you can listen back later.
You can't
give me.
Just use 8-inch per mile per square mile. You can't just use 8 inches per mile squared and just run with that. There's observer height involved in that, and there's refraction involved in that. And that's what you didn't listen to me.
It doesn't change the geometry of what's supposed to be true. It doesn't change the geometry of what's supposed to be your sphere. It's not changing that geometry. You understand?
No, but
your globe is the size it is. It has a radius of 3959 miles, 3,959 miles. That's the radius, which means it has a circumference of 24,940 or whatever. That's what it is.
Like I said, the bottom line, I'm not worried about that
geometry of your globe.
I don't listen to you. You ain't listening to me. But it's all that aside. You say I don't understand sunsets, and no, you don't understand them. You don't understand how
I have listened.
Get higher.
You ask for explanations, and then when I give them to you, you don't even remember what they are because you weren't listening in the first place. You didn't want an explanation. You wanted to tell you something and then argue against it.
No, how can I go higher and see the sun? But I can't see the sun again if I look through a fucking telescope as soon as it disappears. Do you know how?
No, you can't see the sun if you look through a telescope. How do you know that?
What do you mean? How do I know that?
How do you know? Did you do it?
I don't need to do it.
Yes, I know. Just be honest.
I know I've never did it, but I don't have to.
How do you know it doesn't work then?
I've seen other observations.
I think what Brian's asking here is it a faith-based thing that you have rather than rather than and have actually gone out and done it yourself? Is it a faith-based thing?
No, it's not faith, and I ain't gonna listen to a religious globe Earth fucking bullshit because flat Earth is.
I meant because you haven't actually gone and done it yourself, and you're relying on other people to provide you with this information. Would you agree then that is taken on faith? That's taken on trust.
Okay, so how much of his is taken on trust? Brian,
listen, I'm not interested in turning it around onto Brian. I'm just asking you a question. Like normal people would ask somebody a normal question. Just saying, if you haven't performed it yourself and somebody else tells you something, would you agree then that it's taken on faith and trust?
No, I've never done that. But I don't have to using other observations, like a drone observation. When I can go up high and I can see the sun set again, and then when the sun sets, higher, set again.
That's not the point of the telescope. Yeah, when you go higher, you have a bigger angle of view. That's all it is. When you go higher,
still one of my
bigger angle of view.
I go higher in the sky doesn't mean I can see from Brian.
You said 1 second. You said about the telescope.
Okay, right. Listen, Brian, you have an image that you tried to present before, but we got sidetracked with it. Before we round up, is there a chance you could just show that on screen? And if you've got time there, Don, would you just give it a quick cursory look over, just to give your opinion on it? It's basically 2 platforms with a horizon behind it. I'm sure you've probably been made aware of it in the past week or so. It's been doing the rounds. And is it possible that you could just give your own opinion on what you actually think's going on here? It's what Brian's sharing right now.
Are you talking about the one that Sleeping Warrior did?
Yeah.
Posted.
Here it is now.
Video.
Screen out on.
Video actually proves nothing. I mean, that video absolutely proves nothing. It absolutely proves a globe
Why
Earth.
do you say that, though?
I mean, that's only because you can see that part of them oil platforms are missing. Oil platforms are 200 feet above.
Part of the platform is missing. Other than whatever under the water.
About 200 feet above the surface of the water.
What's missing?
The bottom portions of the further back one.
There's nothing missing at the bottom. You can see the horizon behind that. That's just around that. You know, it's not going to be with the water undulating around it. It's not going to be. You're not going to get exactly from observation. You're not going to see the water exactly hitting a particular part on the stanchion.
The horizon, the horizon's behind them. What's the point? The
horizon should be 1.2 at the furthest 1.22 miles away. The furthest 1.23. Right? It should be your hard horizon of your globe. Right? Should be 1.22 miles away from the camera lens if it was a globe. Yet it's over 10 miles away behind both of those oil platforms, and both of those oil platforms, right, have different atmospheric effects happening to them. So there isn't a uniform effect happening to them. So the only way that you could even see that on a globe would be that if the horizon was 1.22 miles away, and these were being loomed up above and behind the horizon. But unfortunately, the horizon is 10 miles away. And for them to be loomed up, they would need a uniform atmospheric effects across, not a different atmospheric effect on the ones that's further away and non-hourly on the one that's close. That is impossible on a globe. This image is not possible on a globe.
So
it's impossible, Don. All the refraction in the world is not going to change that, because the only way to explain that on a globe would be if you had an horizon at 1.22 miles and they were loomed up above and behind it. But the horizon is over 10 miles away. So the horizon is heading for 8.5 to 9 miles further out than it's supposed to be on a geometric edge of a globe. It's not there. It should be at 1.22 miles from a 1 foot observer height. And that camera might have even been slightly lower.
Because you say this, it doesn't mean it's true. You don't know refraction. You don't know what kind of refraction was there during that day. None of these things. You're looking at a picture. You're looking at a picture and you're saying, this is how this should be. When you have no formal education.
No, this what we're seeing here is exactly as it should be, because this is showing the flat earth we're on. If we were on a globe, the hard horizon would be 1.22 miles away. It's not there. You have to have that. The only way you can see these things that far away on a globe is that if you have a hard horizon at 1.22 miles and they're then loomed up above and behind the horizon. But the horizon is past them. So the horizon is about 10 miles away, maybe even more, I don't know.
Looming and refraction are the same fucking thing.
Looming for that to happen on the globe, it means there has to be loomed up from behind the curve. Right? It means behind the horizon. We don't see that.
Looming and refraction are the same fucking thing.
Looming is part of it. Part of refraction is looming.
It's part of the refraction
there's
index.
Looming,
so
there's towering, there's sinking,
you don't know,
and there's mirage. I think they're the four.
You don't know any of that. You don't know none of that, man. And that's my whole point. Is that
possible? All the explanations of refraction in the world this is not possible on a globe.
I think
whatever you want to say, but true. And I don't like pictures. Because I wasn't there, I don't know what the day was. I don't know any of the measurements. I don't know none of that. And here's another thing.
Well, hang on. One thing. Just to confirm what Brian's saying there is that when looming happens or refraction, you need it to go around something. You need it to go around an edge, and for looming to happen, you have to have the edge in front of the object that's being loomed. You can't have the objects in front of the horizon if the horizon is physically before the objects, because that would work in reverse. What you need to see this image, you need to see the horizon, and then you need to see the objects loomed above that horizon. You cannot physically place the horizon behind the objects, because in your geometry the horizon is before the platforms. So it's kind of like a really tricky observation for you guys to explain, and I don't expect you to come up with an answer if you don't have one, because trust me, the Globers have tried, and the Globers don't really have much of an answer for this particular observation.
That's why I can give him the same thing. I can present shit to him that he cannot explain, except with all the word salad that he's said all day today. He's answered no question.
I didn't give you what was honest all night. I didn't give you any word salad. I was very honest with you all night.
Word salad, and you proved and you answered zero of my questions.
And on top of that, when I explained stuff to you, you couldn't tell me what I'd say. You weren't listening.
You didn't answer why we don't see the sun change in angular size. You didn't
change in angular size slightly.
You didn't answer what?
It does change very, very slightly in angular size, but I explained to you why we don't see much of a change. I explained. I sunset to you. I gave you an explanation of the sunset, and you weren't able to say it back to me an hour later because you didn't listen.
Because you say we wouldn't see much of a change doesn't make it true, Brian. Because we fucking actually would.
My explanation it would. With the explanation I gave it would. With the explanation I gave it would, but you didn't listen to it. So you can listen back to the thing and listen to it then. Because I'm not telling you the second time. I told you once already. Listen.
I don't see it. It doesn't happen. So how can you say that the sun?
You have to. For you, the sun is going down behind the curve of the earth, the edge of the globe. But yet, this picture, where is the 1.22 mile edge that should be there? It's not there. Where is the 1.22 mile edge? It's out here, 10 miles away.
Explain sunsets, and you can't explain sunrises.
You have to prove, right? Drop and curvature, right? That matches 24,540 miles circumference of an equator. You have to prove that before you can start asserting that the sun is going down behind it.
What geometry does that happen?
Curvature in the first place. How can you be asserting the sun is going down behind it? You cannot.
I'm sitting in it disappears, and I go up 100 feet in a drone, and I can see the sun again. Then I can watch it leave again.
I go up angle of view. You understand what angle of view is? Your angle of view is better. When you have a bigger angle of view, you can see further.
Happen on.
It's just the way it is. You go higher, you can see further. You can see further because your angle of view is better. This is why. Look,
it's your eyesight, Brian. Just because you
go above the water with his camera, right? And that's a very good camera, and you can see 10 miles. That's as far as you can see in good conditions. Because
the change. Your eyesight is your eyesight. The vision, your acuity does not change the higher you go up. Bullshit.
Your angle of view changes.
It doesn't.
Angle of view. You can see further because your angle of view is better. This is not just something I'm making up. This is a fact of optics. This is a fact of fact. This is a fact.
Lines don't.
Globers in the chat. Would you please say if I'm right or wrong concerning that?
And it's parallel to the Earth's ground. It will never intersect Earth's ground. Never.
When you
the sun will never intersect. It will
view is better, so you can see further. That's just natural. That's just a natural. It just happens. It's just a natural.
We shouldn't be able to
have to explain that to you. You're a grown man. I shouldn't have to be telling you.
You haven't explained that. Sorry, but your junk ass word salad doesn't work.
Well, I missed that part. What didn't I explain? Because you kept talking while I was talking.
Because you didn't explain. You just keep talking shit that makes no sense to me. You can't tell me that, because we go up higher.
Just because it makes no sense to you means that it's shit. Makes
so what line does stop, Brian? What line does the sun go under when it gets further away that makes me be able to see it when I go up higher, Brian?
Prove drop and curvature before you can say the sun is going down behind something, number one. Number two, your angle of view when you go higher is better. That's why your angle of view is better. That's why you can see further. It's just a natural thing. There's no curve needed for that. Doesn't matter if it's a flat or a globe. That won't change that thing. Whether it's flat or a globe, if you go higher, you'll see further. It's just the way it is.
You can't get around it. The sunset proves fucking curvature. It proves it 100%.
Hold on, guys. How have we gone from this image to the sun?
Yeah,
I'd just like to sort of like bring it back to reality, because here we are on our plane or our globe, whichever way you decide to look at this, and we're looking across some water here, and we're seeing a horizon that's beyond the platforms. And the simple question on the table is, how on your model can this be an effect?
Because they ain't letting me speak. The fucking sun, how's the sun going to drop below the earth if it's parallel with the ground?
What has that got to do with this picture, though?
What's it got to do? Is that proves curvature, Brian. If I go up higher and I can see the sun, then when it just
proves you believe something, it doesn't prove curvature at all. You haven't proven curvature. It does. You have to prove curvature. Curvature and drop. At 24,240 miles, it has to be in line with those mathematics, right? You have to prove consistent curvature in line with
geometry.
940 miles.
Shape does that?
Right. Before you can shape that the sun is going down.
You can't. And you won't.
Hold on, guys. Don't talk over each other. You know, at least round it up properly. Come on.
Man, I'm ready to call it. We've been like 4 hours. They're talking. This guy's like talking. He don't listen. He don't fucking. He don't get it. He just won't answer it. He can't answer it, and he won't answer.
I'm not the one who doesn't listen. There was nothing you said. Hang
on. I'll tell you what I'm going to do. I'm going to allow you a couple of minutes to round up each other's point. You know, well, your own sort of like surmise of this particular debate. So, right, I'll tell you what I'll do. In fairness here, what I'll do is I'll allow Brian to go first, and then I'll save the Don to actually finish up. So, Brian, if you want to sort of like say how you feel this went.
I'm happy with that first.
Wait a minute. I'm going to mute myself, and I expect him to do the same when I'm finished.
Yeah, I would too. Yeah. So go ahead, Brian.
Okay. How I sum this up is that, in my personal opinion, is that Don needs to get more into reality and realise that he can't contradict himself within a debate and still expect the other person to go along with what he was trying to assert in the first place. Don needs to learn the difference between an open and closed system. Right? He needs to understand that a sunset is not proof of curvature and drop, that he hasn't proven curvature and drop in the first place. So you have to prove that before you can say the sun is going behind it. Right? I just don't see... Don actually is not a bad debater, as in he's willing to give it a good, it's a good show, right? But he has to understand that when he's wrong on something, he's wrong. He needs to accept that he's wrong. He was wrong about several different points. He asked me for explanations, and when I gave him, later on he couldn't tell me what I gave him, right? Which told me he wasn't listening to what I had said. Right, so if he's going to debate people and he's going to debate me on this subject, then he has to be at least listening to what I'm saying, because there's no point me giving an explanation and him not listening, because he wants an explanation, I give it and then he doesn't listen. That's pointless. In my opinion, Don just needs to accept when he's wrong, and there's many points he was wrong about in this, and it's not just people on our side will say it, it's people on his own side will say he was wrong. Right, so I'm not claiming a win here or anything like that. I'm just saying that Don needs to accept when he isn't correct about something. Right, and when he's contradicting himself, and know the difference between what proof is and what isn't proof, because a sunset does not prove curvature and drop. If you knew for definite there was curvature and drop, and you knew for definite that we're on a spinning globe that's turning away from the sun, then you could say it looks like the sun is disappearing below it. But you haven't proven rotation and you haven't proven curvature and drop, so you can't be saying that's what's happening with a sunset. And just because he finds that flat earth explanation hard to deal with doesn't mean that it's not a valid explanation. Or, well, I say my explanation, because I can't say it's for everyone else in flat earth. Because he can't understand or can't take in my explanation and doesn't take that in and understand it, doesn't mean it doesn't have validity. Okay? What I will say is that I have yet to find curvature and drop and rotation. So, I didn't really have a closing statement.
Okay. Well, thank you very much.
You're going to cut me on the hop there.
Right. Okay. Don. Would you like to round up how you felt this went, and where you feel that you actually won, lost, or what Brian did or didn't do?
All right. First of all, I don't look at this as a win and losing thing. I look at it as just talking. So here we go. Here's my issue is this. Brian didn't understand an open or closed system. He tried to tell me that Earth wasn't a closed system, and you read it right from the website saying it was a closed system. So when he's saying that I didn't know, he's wrong. I was absolutely right. The fact that he doesn't understand that we have to exert forces to overcome the gravity that he doesn't accept to leave this closed system is not my problem. The fact that he didn't listen to me when I said that 8 inches per mile squared is not our globe Earth math, because it includes observer height, refraction, and all them things are included into that. It's not just simply saying, oh, it drops 8 inches away. It's not that simple. And again, the what else? Oh, the angular size of the sun. He can't get around the fact that the sun would get 3 to 4, 5 times bigger as it moved closer to each person individually on their position on Earth, and then it would shrink again 3, 4, 5 times smaller as it went away. And it just does not do that. And to say that, oh, it changes a little bit, it wouldn't do that. It wouldn't change a little bit. It would change dramatically. It would be like a ship in the distance coming towards you and passing you next to you as you standing on the fucking shoreline. It would be small, bigger, humongous right beside you. Then it would get smaller as it went away. Its sun would do the same exact thing that ship does. You can't put perspective in on one thing and not apply to everything. Laws of perspective apply to everything that is visible. Just because I don't know what the sun is or what it's made of, that doesn't matter. We see it, therefore it observes the law of perspective. Can't get away from that. Other than that, I'm not being able to over talk him very much. That wasn't the main issue. Only issue I had is that I didn't get really to, every time he said a question, I couldn't answer it because he was talking on and on. But that's fine. I'm sure I did that too. That's part of a heated debate. But other than that, had a good time. I'm not an expert in everything. I just know what I know, and that's what I know. So, and Earth and the sun does, by the way, the sun does prove curvature when you can go up higher and see it set again. Go up higher, see it set again. The only shape that applies to that would be a sphere. No other shape. A flat surface, it would not do that. Because I go up higher doesn't mean I can see further. If the sun is out of my eyesight, just because I go up high doesn't mean that I can see that object that went out of my eyesight again. If I was looking at a plane and it went out of my eyesight, just because I went up 100 feet doesn't mean that I could see that plane again with my eyes. And that's all I got to say about it.
Okay. So what I'm going to do now, guys, if you just want to sort of like listen in, what I'm going to do is I'm going to take you off the audio so that the audience can't hear what you're saying. I'm going to unplug my ears so I can't hear what you're saying, but I want you to hear what I'm going to say in my closing statements, because I think it's quite important for the both of you. So bear with me. Okay, so here we go. Okay, so my ears are unplugged, so I can't hear these guys, so I'm not going to get distracted right now. But one thing I would say is that we had a good 3.5, maybe close to 4-hour debate there, and I have to say, I mean, Brian went very easy on Don, in my own opinion. There was plenty of opportunity in the early beginnings where a lot of this argument that went on could have been laid to rest very quickly and very easily. Being a part of the Flat Earth debate team for the past 2 years, personally, and being instrumental in that, it's kind of like, we've come across these arguments so many times, and when you get drawn into these back and forths, it ends up in this region of a kind of like a lost argument. There was also some things that I would say for Don. Don needed to perhaps know more about his own model, more about the 8 inches per mile squared, etc. More about, just a whole bunch of things that he perceived to be What he thought was real science was in fact actual just pseudoscience. There was a lot of presupposition. There was no definitions as to actually defining what the sun is. We've never been there. The actual going to the moon and stuff. There was a whole bunch of things there that could have been improved on both sides. I mean, this could have been, a lot more. How would I say? It would have been a lot more cut and thrust, especially if like Nathan had been on, or Quantum Eraser, or maybe even Bob, from Globebusters, But this would have just gone. But I suppose that's a learning curve, and this is a good way of showing how when you bring the globe earther in to discuss with a flat earther, and we get stuck on points and definitions and stuff, it really becomes a circle jerk kind of thing. And, as much as I'd like to say things were accomplished, but they weren't accomplished as quickly and as swiftly as I would have liked to have seen. But all in all, the guys, they stuck to it for 3.5 hours. They debated each other. I mean, what can you say, guys? They entertained you for the past 3.5 hours. It's excellent. And I'm sure they'll go away, watch back, listen to the arguments that each presented, to the things that they brought forth, maybe refine some of the things. And if they want to do this again, I'm happy to be the moderator again. This is all new to these guys. I'm sure that Don hasn't been on a debate platform before. Brian, I think, has maybe just had one debate in the past. So, got to go easy on them in the comments, guys. And it is what it is. And I enjoyed it very much. And I thank everybody for stopping by. At one point we had close to, I think, 180 people watching, which was pretty good. We're bound to have had over 1,000 watching in total up to now already, so that's pretty ace too. I don't know when I'm going to be back. It will be this week though, at some point, probably later on in the week. So thank you all for stopping by. I am definitely going to have a day off tomorrow because it is my 6-year anniversary with the missus. It's the first time we met 6 years ago, so I've got to spend the night with her. I can't keep spending my night with you guys. I need to at least look after the lady one time. So with that being said, thank you all for stopping by. Thank you all for the people that gave a super chat. I do appreciate that, and I will see you all in the next one.